Morning, everyone. So, good morning, everyone. I hope you people are doing great. Okay. So, let's come to the yesterday's session first. So, in yesterday's class, we have discussed the different type of failures and different theories. Terzaghi's theory we discussed and Rankine's theory we discussed. So, based upon that, I have given you the problem also. So these are some of the things we discussed for different soils. I told you for phi is equals to 0 degrees, you need to remember it as NC, NQ, and gamma. And for various shapes of footings, you have to go for this. So the changes, and we discussed about the effect of water table also, then effect of local shape failure. And then we discussed about the Skempton's theory. So in the case of Skempton's theory, again we discussed about the means after that we discussed about Meyerhof theory by including the inclination, depth, and shape factors also. So with this we have completed almost all the things analytically. The analytical procedure has been done. Nature is not allowing us to do great, sir. What to do, sir? We just have to flow. We just have to go with the flow. And one side locust attack, other side COVID, and from other side there is cyclone attacks. So we cannot do anything. Just wait and watch. Enjoy the show, nature show. Okay. Now I'll be discussing one more thing. See, so far and so good. Only dead fish go with the flows, goes with the flow, and that's one of my caption only. But right now we are dead fish. We cannot do anything, and man cannot go against nature. I mean, as we have gone through against nature so years or so many years. So that's the reason why we are encountering all these situations. Okay. Yes. See, so far, whatever the discussion we made, whether it's a Rankine's theory or Terzaghi's theory, the load that we applied is a concentrated load. Okay. Whatever the load we applied is a concentrated load. But in reality, do you think always the load is going to be concentrated? In reality, do you think always the load is going to be concentrated? No. So in reality, if the load is going to be something like eccentric loading, then how we are going to approach? Look, whatever the theory, whether the theory is going to be Rankine's theory or Terzaghi's theory or Skempton's theory and Meyerhof theory. So all the four theories has assumed the load acting on the footing as a concentrated load. Means the column is a concentrated load. But in reality, the load means the footing may be concentrated or eccentric also. So now if I give you an eccentrically loaded footing, how to analyze that? For eccentrically loaded footing, eccentrically loaded foot. So now if you observe, let's see, look, if it is a column but the footing is not going to be concentrated right now. Now, if you observe, it is not going to be concentrated. It is no more concentrated. Yes. Okay. So now, whatever the load that I have done, whatever the load that we have done. So if we see the load that I am applying, this is going to be Q, and mind it, this is a center. This is a center. Whatever, this is nothing but the center. And if you observe, this is going to be the loading axis. So whatever the load, this is going to be Q, and what is this is nothing but the loading axis. So everybody, now you tell me, does the load is passing through the center or eccentric? So this is the center. See, the meaning of concentric means load passes through center. The meaning of eccentric means load passes away from the center. So as the load is going to be passes away from the center, now let's take whatever this eccentricity in the width direction as Ex. Whatever the eccentricity in the x direction or width direction as Ex. And you know that whatever this width, this is going to be B by 2. Yes, whatever this width, this is going to be B by 2, because you know the total width of the footing, right? You know the total width of the footing is going to be B. So now, whatever the load that I am taking over here, this load is acting at an eccentricity of Ex. Then what about this remaining value, sir? This remaining value, see, the half of the distance is going to be B by 2. And if it is going to be Ex, then what about this value? B by 2 minus Ex. So I hope you understood what I have written over here, where Ex is eccentricity from center in width direction. So now let's take the plan view. This is a section view, right? This is section view. Let's take the plan view. So in the plan view, you know, this is nothing but a width. This is going to be width B, and here it is going to be length L. So in the plan view, whatever, this is nothing but the center line, right? So here is going to be center line. So mind it, my dear student, this is going to be the center line, and this point is the center point. So if in the case of the plan view, if it is a rectangular footing you take, or square footing, or any strip footing you take, this is the center. If the point load is going to be passing through the center, then we call it as a concentrated load. Then we call it as a concentrated load. Understood or not? So now, whatever this point I take, this point may locate somewhere over here, or here, or here, anywhere in this axis. Yes or no? So anywhere in this axis it is going to be located. Now let's take my point is located Okay. So let's take my point is located over here. If I say my point is located over here, now, my dear student, you please tell me, away from the center, this is going to be located at a eccentricity of Ex. In which direction? Width direction. See, you can see the width direction, and whatever this value, this value is going to be b by 2 minus Ex. Whatever this value is going to be b by 2 minus Ex. So, if you observe here, in the width direction, I am showing you in this width direction, the eccentricity is going to be Ex. And similarly, from the center, in the y direction also, there is some eccentricity Ey. In the y direction also, there is some eccentricity Ey. So now you tell me, what is this length? What is this length, please? This length is going to be L by 2 minus Ey, because whatever this value L by 2 minus Ey. So you please observe, with the center, this is going to be b by 2 and this is going to be L by 2. And if the load is going to be acting somewhere over here, this is going to be the loading action, eccentric loading action, then the load is no more concentrated. If the load is going to be acting over here, it has some eccentricity in X with direction and it has some eccentricity in Y. So what is a Y, sir? Eccentricity from center in length direction. So is it a two-way eccentricity or one-way eccentricity? This is going to be two-way eccentricity. Here it is going to be, this is a two-way eccentricity. In the case of the two-way eccentricity, Ex and Ey both would be there. And in one-way eccentricity, Ey is equals to 0. Sir, what is the meaning of Ey is equals to 0, sir? What is the meaning of Ey is equals to 0? Then the point will locate over here. So if the point is going to be located over here, then what is the eccentricity we can see from center? Only X direction Ex. So I hope you can imagine this. So my footing is going to be located over here. This is the point where my footing is going to be located. Means my column is going to be located. And this column has an eccentricity of Ex in the width direction and Ey in the length direction. Now, my dear students, how to approach this? Sir, whatever the theories I have explained so far are concentrated load. Now this is an eccentrical loaded. We have two options. Either you create a new theory for the eccentrically loaded, or you have to use the existing theories. Sir, if I want to use a new theory, then it will be more time. And if you want to go for the existing theory says that load must be concentrated. So now we are going to convert into equivalent concentrated point load. So in order to use or apply existing theories, eccentrically load loaded footing should convert to equivalent concentrated load. Equivalent concentrated load. Sir, how it is going to be possible, sir? Now you see, sir, the same thing that I am going to take. Again, the width is going to be B and this is going to be L. These are the actual dimensions of the footing. But you know that it is going to be having some eccentricity. So this is the eccentricity, right? Yes or no? And what about this length? This is going to be B by 2 minus EX. You see, please, this is going to be B by 2 minus EX. And what about in the length direction? This is going to be L by 2 minus EX. Yes or no? Now, keep that in your mind. If you want to make sure this has a center, if you want to make sure, see, the eccentrically loaded footing should convert to equivalent isotropic loaded footing. Then if I want to make sure this has a center, then I have to draw one more footing. Now you observe, see, if I take the rectangle, please listen. If I take the rectangle, whatever the rectangle I have drawn with the red, then for this red rectangle, this point is going to be behaves like a concentrated point or not. You see, the eccentrically loaded footing should convert to equivalent concentrated load. At first, for dimensions of L and B, this point is eccentrically loaded. But now, as I take, if I want to make sure this is center, whatever this distance should be the same in the other distance. Now let me take this as a B dash and this is going to be L dash. So now you tell me, if you want to make sure, in order to apply the existing theories, eccentrically loaded footing should convert to equivalent concentrated load. Now where B dash where B dash is equals to 2 times of B by 2 minus EX, because you know whatever this width is going to be B by 2 minus EX, and if you add the same width on the other side, then this point is going to be exactly at the center. This is B by 2 minus EX and this value is also going to be B by 2 minus EX. So B minus 2EX. Similarly, L dash 2 into L by 2 minus EY. L minus 2EY. So what is B dash? B minus 2EX. What is L dash? L minus 2EY. In simple words, when they give you the eccentricity, then you have to take the dimensions as L dash, B dash, not as B and L. Not as B and L. Sir, then once we convert this, then what is the loading, means ultimate bearing capacities are here. The ultimate bearing capacity QU is equals to, come on my dear students, CNC. Is there any effect? Plus surcharge gamma dNq plus now 0.5 gamma. Now here B is there or not? B becomes B dash into N gamma. B becomes B dash into N gamma. See, this is the total width of B and he is going to be B dash. So now whatever the equation we got at the end, this is the final equation in order to determine the ultimate bearing capacity. See, everybody, if you look What is the only change that you can observe? The change is going to be this B becomes B dash, right? That's it. And how the B becomes B dash? Now this is the point. In order to apply the existing theories, eccentrically loaded footing should converge to equivalent central load, sorry, equivalent concentrated load as A dash is equals to B dash into L dash. What is A dash, sir? Area. What is area, sir? B dash into L dash. And what is B dash? You know that. I hope you understood. Please have a look once. Just simple. The means the total load means the total rectangular dimensions BL. I converted it to B dash and L dash. So if I convert that, then this is going to be the central load. And you can apply the existing theories. This is the existing theory or not from Terzaghi. Yes, this is the first slide, my dear. Come on, have a look, please. Whatever this width, this is going to be B by 2 minus EX. And whatever this length, this is going to be L by 2 minus EY. So that's the reason why we multiply with R2. Sir, so QU is independent of length. See, in the case of QU, there is no length term. But in the case of the area, there is a length term. I'll tell you. Wait for that. In the case of area, there is a length term or not. Area is going to be affected. What happens to remaining rectangular portion? We don't consider the remaining rectangular portion. That's the meaning of equivalent concentrated load. We don't consider the remaining portion. If it is a one-way eccentricity, it can be in width direction, not on the length direction. So you please note that. Note, in one-way eccentricity, eccentricity in the width direction is going to be 0. So no change in the length. Because see, why I am taking, sir, in one-way eccentricity, y direction means length direction 0. Why? Because I am dividing, means I am defining the entire theories with respect to width direction, right? So that's it. Now, that's about the eccentrically loaded. So we discussed about the inclination. In the case of the Meyerhof, inclination, shape, depth, and in the case of this eccentrically loaded, we have discussed about the eccentrically loaded also. Now, that's all with the completion of analytical procedures. Now, let's solve some questions. Yesterday, I was discussing this question. Now, while I was discussing question, we have, power issues. So I got a power issue. Those means I have discussed up to this point and I gave you this value. I hope you understood. Keep that in your mind. Again, I'm telling you, my dear students, when they give the question, at first, I read the question, a footing 3 meters square. Listen to this question again. First, at first, a footing 3 meters square carries a gross pressure. So gross pressure means the total pressure acting, 350. And the footing is at 1.2 meters depth. Yes. And the unit weight above the water table is going to be 17. And below the water table is going to be 20 kilonewton per meter cube. The shear strength parameters they have given C dash and phi dash. Determine the factor of safety with respect to shear failure. So water table is at 1.2 meters. So I took the water table is at 1.2 meters. If the water table is at 1.2 meters, then the water table is exactly at the base of footing. So at first, as a footing is going to be square, I write down the equation 1.3 CNC plus gamma DNQ plus 0.4 gamma B and gamma. Then I apply the condition. Water table is at the base of footing. Means below the base, soil is submerged, gamma dash. Above the base, no submergence, gamma. And as they mention C0, then I can remove the C value. Then I got this equation and I want a whom factor of safety, which means I need to go for the design condition. What is the design condition? Q less than or equals to QS. Then I can write Q is equals to QS or not? Yes. So what is QS? Net ultimate bearing capacity by factor of safety. Net safe plus gamma D. So I can write the net ultimate as QU minus gamma D. So gamma D NQ minus gamma D into NQ minus 1. So now once we got this, then we are going to apply over here. I applied over here. See if it is a net ultimate, mind it, I'm going to write as gamma D into NQ minus 1. So then I directly applied here and I find out the factor of safety. So first thing, what is the type of foundation they have given? Apply the conditions and what is the design condition. If you know these three, then you can apply, then you can find it out. Now, let's come to this question. This is also same type of question. Let's come to this question. Then you can understand much more better now. So now coming to this, size of an isolated footing is to be limited to 1.5 meter by 1.5 meter, which means given is a square footing. So immediately in your mind, square footing, okay, the equation should be there, 1.3 CNC plus gamma DNQ plus 0.4 gamma B and gamma. So width is going to be how much? 1.5 meter. Now, calculate the depth at which the footing is going to be placed to take a load of 1962 kilonewtons with a factor of safety of 3. So the load, net load, what is the meaning of net load, sir? The net load means load coming from the structure only. So the net load is given as 1962 kilonewtons and the factor of safety is going to be given as 3. The soil is having angle of internal friction phi 30 degrees. Self weight of the footing and backfill is 5% of the external load. So this net load or external load, I can say external load is nothing but net load. Okay. Now, what is the gross load? I told you the differences between the net load and gross load. Gross means total. Net load means external load plus self weight of footing and backfill. So gross load QG is equals to net load 1962 plus is 5% of the external load, right? 5% means 5 by 100 of 1962. See, they have given the external load and it is going to be having some factor of safety. Factor of safety means you designed for safe. Yes. Now, what is the question I am asking you? Depth. So find out the gross load, please. What is the gross load? If you find out the gross load, that's going to be 2060.1 kilonewtons. Once you know the gross load, then the gross pressure is nothing but gross load by area. 2060.1 by area of footing, 1.5 into 1.5. So I got the gross pressure as 915.6 kilonewton per meter square. 915.6 kilonewton per meter square. See, what I done is I constructed a footing, and if this is the footing, if this is the footing, so now this is going to be the ground level. What they're asking is, what is this depth of foundation? What is the depth of foundation? So now they have given the net load. The net load is given as 1962. But what is the total gross pressure over here? The gross pressure I got it as 915.6 kilonewton per meter square. That's the gross load. Okay. Now means gross pressure. Now we need to design. Whenever the design condition comes into the existence, you know that design Q less than or equals to QS. Q is equals to QS. What is QS? QNS plus gamma D, which means QNU by factor of safety plus gamma D. Given is going to be square footing. Then what is ultimate bearing capacity of the square footing? 1.3 CNC plus gamma D and Q plus 0.4 gamma B and gamma. 0.4 gamma B and gamma. Now you go back. See, they have given nothing regarding to the C value. As they did not mention any C, then so here you see, observe, is there any NC value also? No. C is equals to 0. As they did not mention in the question, I am going to take C as 0. And there is no water table, right? No water table, and C is equals to 0. And what is QNU? Gamma D into NQ minus 1 plus 0.4 gamma B and gamma. So why you take QNU as gamma D into NQ minus 1, sir? Because you know, sir, what is QNU, sir? Ultimate bearing capacity. Ultimate bearing capacity minus gamma D. So gamma D NQ minus 1. Gamma D into NQ minus 1. Just simply substitute this one. If you do so, then Q is equals to gamma D into NQ minus 1 plus 0.4 gamma B and gamma by factor of safety plus gamma into D. My dear student, you please observe this question. What is this equation? At the end, what is the equation I got? You please observe. This is also square footing. And one more, the more than that, C is going to be 0. And there is a water table. So here gamma D and Q minus 1 plus 0.4 gamma dash B and gamma. Here also the same equation, right? I hope you understood now. See, what I'm doing is, first I look over the type of footing. Is it square, rectangle, circle, strip? Then I'll find out what is the net load or gross load, net pressure or gross pressure. Then I go for the design condition. In this question, I asked you whom? Factor of safety. The question we asked is factor of safety. And they have given D and they asked a factor of safety. And you see in this question, I gave you factor of safety, I am asking you D. So please substitute over here. Whatever the Q value I got is 915.6 15.6 is equals to gamma. What is the gamma they mentioned? The unit weight of the soil. See, this is unit weight of the soil. Gamma is 20.60 kilonewton per meter cube. 20.60 kilonewton per meter cube into D into NQ. What is NQ value given? NQ is 22, N gamma is 20. Minus 1 plus 0.4, 20.60 into B, how much? 1.5 into N gamma, 20 by, what is the factor of safety? 3 plus gamma into D, plus gamma into D. Or I'll write directly. Please look over here. What I do is, you know the factor of safety as 3, right? You know the factor of safety as 3. Take out the LCM. If you take out the LCM, gamma D into NQ minus 1 plus 0.4 gamma B N gamma plus, what is this LCM? LCM is 3 gamma D by 3. 3 gamma D by 3. So even I explained this many times, sir, can you again explain why you took NQ minus 1 instead of NQ? I did not got. Array by AQU, AQNU. The QNU means QU minus gamma D. You substitute minus gamma D and you can remove the gamma D as a common, then you can get it as a NQ minus 1. So now if I take the LCM, then if I take the LCM, that is going to be 3 gamma D. So now you please send this inside. You please take this to the other side into 3. Now again gamma D NQ minus 1 plus 3 gamma D. What is mean by here? Gamma D, you please take the gamma D common. You please take the gamma D common. Here there is a gamma D, here there is a gamma D. Gamma D common. NQ minus 1 plus 3. NQ minus 1 plus 3, which means NQ plus 2. So I can write this one as gamma D into NQ plus 2, 0.4 gamma B and gamma. So 915.6 into 3 is equals to 20.60 into D into, what is our NQ? 22. 22 plus 2, 24 plus 0.4 into 20.60 into 1.5 into, what is this value? N gamma is going to be 20. The only unknown here is D. The only unknown is going to be D. So find out, and the D value is going to be 5.05 meters. If you solve it, you're going to end up with 5.05 meters. Sorry, in first problem, water table is at base of footing. By approximation method, water table correction is not applied. No. See, the approximation method is not going to be applied until or unless they asked. You want to go for approximation or exact method? Exact, right? Here, the logic is I don't write all these things directly. See, the logic is I'll write with one single step. The logic for this question is I'll write one single step. Now keep in your mind, you know that Q is equals to QS. Q is equals to QNU by factor of safety plus gamma D. Yes, my dear student, when I give you the question, immediately you have to understand what is the questions. Go back over question. What is the thing that you need to understand over here is, what is the type of footing it is? Square. Immediately in your mind, the square footing ultimate bearing capacity should be there. Okay. And I mentioned C is equals to 0. Okay. You know that ultimate bearing capacity has three effects: cohesion effect, surcharge, and width. If C 0, then cohesion effect is going to be 0. Then cohesion effect 0 means, then what else remaining we have? We have surcharge effect and we have width effect. And when I say net ultimate, then you are going to minus gamma d or not. So in the surcharge effect, gamma d n cube minus gamma d, which means gamma d into n cube minus 1. So after solving all these type of problems, I can directly come to one conclusion. I can directly write this equation as QNU means gamma d into directly 1.3 into CNC plus gamma d into NQ minus 1 plus 0.4 gamma b and gamma. This is for square footing by factor of safety plus gamma d. So in the given question, C is equals to 0. That's it. Step number 1, square footing. Step number 2, design condition. And step number 3, I will apply this and what we require at the end. And I can write this gross pressure also, gross load by area of footing or not. Gross pressure. Pressure means load by area. Gross pressure. Gross load by area of footing. Then we can find out the D value. See, this is just an elaboration. I am giving you detailed procedure so that while you are going to solve n number of problems, you would be able to understand the question easily. So please go through this once. Meanwhile, I'll go and have some water. Please. Yes, you have done. Now let's go for the next question. So in paper, if option very large in water table question, then can we see we cannot go for the approximation method until or unless they mention. I'm telling you clearly. Until or unless they mention, don't go for water table as an approximation method. So for square footing, we cannot directly apply this formula if we remember on time, right? Yes, but do you think you are going to remember these many formulas? No. So now let's come to the next question. Question number 5. Question number 5. You see what is this footing? What is this footing? Wall footing. Wall footing is nothing but a strip footing, right? So now immediately I can see and say the footing is going to be strip footing. Strip footing means per 1 meter length. You know that in the case of the strip footing, the length is going to be infinite, which means you take as per 1 meter. So the net load of net load of 152 kilonewton per meter length of wall. What is the meaning of that one, sir? Sir, you know, in the case of strip footing, the length is more, sir. As length is more, instead of giving the length, they will give you per meter length. Q is equals to 1, net load is 152 kilonewton per meter. Is to be constructed at a depth of 1.2 meters. Subsoil conditions consist of a uniform deposit stiff clay. Stiff clay. So the soil is going to be clayey soil. First of all, I know the footing. Now I know the soil with unit weight. Gamma is equals to 18.8 kilonewton per meter cube and unconfined compressive strength. I hope you remember the unconfined compressive strength in chapter number 13. I hope you remember the unconfined compressive strength. Unconfined compressive strength is nothing but 2 times of Cu is equals to 150 kilonewton per meter square, which means Cu is equals to 75 kilopascals. And did they mention anything regarding to clay? Phi is equals to 0. You know that Nc using Terzaghi. When I say Terzaghi, Nc 5.7, Nq 1 and N gamma is equals to 0. Determine the width of the footing. See, this time I am asking you whom for a factor of safety of 3, I am asking you width of the footing. What is the width of the footing? So I am giving you 2 minutes of time. You try and solve. I am giving you just 2 minutes of time. Come on, solve it. Solve, come on. You know, in the case of clay, what is the net ultimate bearing capacity? See, I am asking you this time width, B. In first question, we find out factor of safety. In the previous question, we find out depth. Now I am asking you width. You know what is the design condition, right? Come on, find out. Try. $450. Yeah. I am asking you width. What you are saying 450? The sir, it's independent of width, no sir. The change is independent of width. The answer should be 1.067. Answer should be 1.067 meters. Sir, should we take L as 1? Yes, you have to take L as 1. They mentioned it clearly, right? For meter length of wall, you have to take length as 1. Okay, fine. If you have not now, those who did not got, listen to me. What is the design condition again? What is the design condition again? The design condition is going to be Q is equals to QS. Means I am writing directly Q less than or equals to QS, then Q is equals to QS. Then Q is nothing but QNU by factor of safety plus gamma D. QNU by factor of safety plus gamma D. So now you write this gamma to the other side, then Q minus gamma D is nothing but QNU by factor of safety. Yes. And what is mean by gross pressure minus self weight? Net pressure is equals to net ultimate by factor of safety. Net ultimate by factor of safety. In the case of clays, in clays, you know that in clays, you know that QNU is equals to CNC. If you have any doubt, you please go back and have a look. So now, my dear student, what I do is, you know that, see, I gave you net load or net pressure? Net load. Yes or no? Net load means net pressure means net load by area of footing B into 1. Why I take length as 1 meter, sir? Because they already clearly mentioned, sir, meter. Length of the wall is going to be L is equals to 1 meter. So is equals to CNC by factor of safety. That's it. That's it, right? See, I can keep that in your mind. See, I told you the design conditions. See, everywhere I am using the same point now. Everywhere I am using the same thing, right? But this time they did not give the gross load. So I send a gamma D to the other side. I convert into net pressure, right? So now, whatever the net load we know, the net load is how much? 152 by B into 1 is equals to 75 into NC 5.7 by factor of safety as a, what is the factor of safety given? 3. So B is equals to 1.067 meter. I mean, you might have, means if you are not getting this one, you might have done some calculation mistake. You please have a look at that. The calculation mistake. So I hope you see how much time it took for me. See the same condition. Have I applied the same condition here? Yes. Have I applied the same condition here? Yes. So you have to look over everywhere this QNU. If you can look over the QNU, then you can understand more. And if you have any doubt in this, you please go back to the yesterday and day before yesterday PDFs. So you can look over there. QN is equals to CNC. Sir, why you didn't take NQ, sir? Sir, Abba, sir, kya hai, sir? What is this, sir? After all this also, why you did not take a NQ, sir? Please have a look, sir. What is mean by QU, sir? What is mean by QU? Tell me. What is mean by QU? CNC plus gamma D and Q plus 0.5 gamma B and gamma. This is for strip footing. In the case of the clayey soils, N gamma 0, NQ1, QU is equals to CNC plus gamma D. QNU is equals to QU minus gamma D. So CNC plus gamma D minus gamma D, gamma D gets cancelled. Then what is the net ultimate bearing capacity in the case of the clayey soils? CNC. That's it. So I gave you the design conditions for the factor of safety. Means I'm using the same condition. I'm using the same condition. When I ask you width, when I ask you depth, when I ask you factor of safety, the load means the conditions are going to be same. Look, I'll give you in the same question. Listen to me. In the same question, I'll give you the width and I'll ask you the net load. I'll give you the width, I'll ask you the net load. Yes, you see this equation, I'll give you the width, then I can find out the net load also. Or I'll give you everything and I'll ask you factor of safety. I can find it out. So I hope you understood this. Let's go for the next question. Now see this question. A building has to be supported on a RC raft foundation. RC raft foundation. I think I'll give you this. Yes, here is a homework for you. This is a Skempton's approach. Okay, fine. Let's solve this one. This is a Skempton's approach. So let's solve this one and then I'll give you some other questions as a homework. A building has to be supported on a RC raft foundation of dimensions. So what is this dimensions? 14 meter by 21 meter. Is it a rectangle or not? So okay, footing is going to be a rectangle. 14 meters by 21 meters. Subsoil is a clay. So you know that clay. Unconfined compressive strength is given as 2 times of Cu, which is going to be 15. Then what is Cu? 7.5 kilonewton per meter square. The pressure on the soil due to weight of the buildings and the loads that will carry will be 140 kilonewton per meter square at the base of raft. So whatever the pressure of the building and the loads that it will carry will be 140 at the base of the raft. And the building has a provision for the basement floor. So when I say the building has a provision for the basement floor, it is a no backfill condition. So now you see, observe. This is a raft of width how many meters? 14 meters. And you see there is no backfill. This is a basement floor, right? Whatever this is nothing but basement. So which means without backfill. When there is no backfill, whatever the load coming from the structure is nothing but the gross pressure. See what is meant by gross pressure? Tell me. The total pressure acting at the base of the footing. See, when I say there is a basement that is without backfill, so then whatever the pressure coming from the structure is nothing but the gross pressure. What is gross pressure? 140 kilonewton per meter square. 140 kilonewton per meter square. Yet what depth the bottom of the raft to be placed? Now what is the depth? The bottom of the raft to be placed with a factor of safety of 3. Take gamma sat as 19 kilonewton per meter cube. But now this time use Skempton's approach. You know that Skempton is applicable for the clayey soils. That's for sure. Yes or no? So again I want whom? Depth. When I want something, what we're going to do is we are going to write the design condition. So what is design condition? The design condition, Q is equals to QS. Q is equals to QNU by factor of safety plus gamma D. And according to Skempton, the net ultimate bearing capacity is nothing but CNC, right? The net ultimate bearing capacity is nothing but the CNC. So CNC by factor of safety plus gamma D. But my dear student, this question and the previous question both are going to be same. But this is Terzaghi. Here this is going to be Skempton. So now from Skempton, NC is equals to 5 into 1 plus 0.2 d by b into 1 plus 0.2 b by L. Yes, this is for rectangle, right? Now 5 into 1 plus 0.2 d we required, and what is the b value? B by L. So 14 by 21. 14. 1 plus 0.2 into 14 by 21. So now can you please tell me what is NC? 5 into 1 plus 0.2 into d by 14 into this value. 0.2 into 14 by 21 plus 1. 1.133 into 5. Okay. 14 by 21 into 0.2. This one. So 1.133. Now you please send this 14 also inside. So now, okay, fine. If you saw all these things, then NC is equals to same equation, right? 1 plus 0.2 d by 14 and 1 plus 0.2 b by L. Okay. So now, if you send this one inside, then 5 into 1.133, 5.665 plus into 0.2 by 14. Is it same, right? B by L, D by B means D by 14. Okay, so should we? Yes, okay, fine. So now you please observe this. Directly I can write here as so okay, 5.665 plus 5 into 1, 3 into 0.2 by 14, which is going to be 0.0809 D. And QNU is equals to CNC. So 7.5 into 5.665 plus 0.0890 D. So the net ultimate bearing capacity is equals to 0.607 D. 7.5 into 5.665. 42.48. So now you can substitute this value directly here. So Q is equals to QNU by factor of safety plus gamma D. What is the Q they have given? 140 is equals to 42.48 plus 0.607 D by, what is the factor of safety given? The given factor of safety is going to be how much? 3 plus, what is gamma they have mentioned? 19 into D. So substitute and find out the D value. Look, sir, there are two formulas. This is for the rectangle ray. This is for the rectangle. So actually we do, means there is a one more formula. it depends upon the d by bf only. So means b by d, it depends upon the d by b, and that's going to be different value. (14 into 21 into L by B kada sir. Baba, the given dimensions, the minimum dimension is width, the maximum dimension is going to be length. In a given dimension, least dimension is width. For ESC, these type of questions have been asked. Don't ask. Sir, why do you self-weight when there is no backfill, sir? Sir, before the construction, what is there, sir? Self-weight of the soil is there or not? You have to consider that. Sir, you have not mentioned NC value square or circular footing in the case of Skempton's theory. I told you, Baba, if you keep B by L as equals to 1, then 1 plus 0.2, 1.2 into 5, 6. That's going to be square. For square, you don't need to remember. If you keep B by L as 1, that's going to be square, right? The D value is going to be 6.55 meters. Yeah, in ESC, they won't give this type of questions. I am giving you this type of models for the gate. In ESC, these type of questions can be expected as conventional questions, means mains. See, this is 97. This is a conventional question, Nana. This is not a prelims question. This is a mains question, conventional question. But this type of models can be expected more in the case of the gate. Now let's see the last question in the classroom practice questions. Please observe this question. A square footing, again they have mentioned the square footing. So given is a square footing, and to an inclined point load, so the load is going to be inclined. When there is an inclined load, I told you there is an inclination factors. Yes, you see in this question they have given the inclination factors. The water table is located well below the base of footing. So water table is located well below the base of footing. So we don't need to consider the water table, because the water table is well below the base of footing means no effect of water table. Considering one-way eccentricity only. What is the meaning of one-way eccentricity? See, this is the center. This is the center. And this is going to be the eccentricity, Ex. So convey means consider only one way of eccentricity means, I told you one way eccentricity means Ey is equals to 0. The net safe load carrying capacity of the footing. They are asking net safe load carrying capacity, which means net load in terms of kilonewtons for a factor of safety of 3. And apart from that, they give, see, this is a ground level. The depth of foundation is going to be how much? 1 meter. unit weight 18, C 0, friction angle 35 degrees. Now everybody have a look. Is it a Terzaghi's theory? No, because they have given the bearing capacity factors, they have given the shape factors, they have given the depth factors, they have given the inclination factors, which means this is based on Mayer-Half. What is that? Mayer-Half. So first of all, write down the equation from Mayer-Half's theory. Sir, how come I know this is a Mayer-Half, sir? Sir, because they have given all these factors, sir. You know that. First, let me write down the equation. CNC plus gamma DNQ plus 0.5 gamma B and gamma. This is normal equation. And when they give the shape factors and all those things, I just told you multiply SC, SQ, S gamma, IC, IQ, I gamma, DC, DQ, D gamma. But you see, they mentioned cohesion is going to be 0. So now you tell me, as cohesion is mentioned as 0, then this term is going to be 0, right? So now keep this aside. What I want is the net load. What I want is net load. So how can I find out the net load, sir? First of all, you need to find out the net bearing capacity, means net pressure, Qn. From there only you can find out the net load. Okay. Now, listen. Given is one-way eccentricity or not? Given one-way eccentricity, which means the one-way eccentricity is going to be Ey is equals to 0. Ey is equals to 0. And what is Ex? Ex is equals to, what is a half? V by 2 minus this value, whatever this value is going to be 0.85. So 1 minus 0.85, which is going to be 0.15. And what is B dash? B dash is nothing but V minus 2Ex. 2 minus 2 into 0.15, which is going to be 1.7 meters. Are Baba, if you are smart enough, whatever this value is nothing but B by 2 minus Ex or not? Whatever this value is nothing but B by 2 minus Ex. Yes or no? That's it, right? Yes. So from the figure I can write, instead of going for all these things, I can write from figure B by 2 minus Ex is going to be 0.85. Now you please go back. What is B dash? B dash means 2 times of this value or not? B dash means 2 times of that value. Yes or no? So they have given this value B by 2 minus Ex as 0.85. So now I can write B dash is equals to 2 times of 0.85, which is going to be 1.7 meters, and L dash is equals to L only. What is L dash? L, because Ey is equals to 0. As there is no Ey, then there is no L dash. L dash and L both are same. Because you know what is meant by L dash? You please go back. What is meant by L dash? L minus 2 Ey. And Ey is equals to 0, then L dash is equals to L. So now, when there is a one-way eccentricity, now B becomes B dash or not? So I am representing here. So you please observe. I'll be representing this value as B dash n gamma. So my dear students, first of all, I see the question. They gave all the factors. So I apply the equation. Then they mention C0. Yes. and they mention one-way eccentricity, then B becomes B dash, yes. So now what I required is going to be the net load. How to find out the net load, sir? Sir, it is a 0.4. No, it's not 0.4. It's not 0.4. How many times I said you? You please go back. See, the purpose of what is the meaning of SC, SQ, S gamma? That is nothing but shape factors, right? What is the meaning of shape? For a different shape, for different factors. In the case of Terzaghi, they did not mention the SC, SQ, S gamma. So, as a shape changes, you are going to apply separately. But in the case of the Meyerhof, this is the equation. And whatever the factors they mentioned, whatever the factors are, these are shape factors. These are the shape factors for whom? For square. If it is a rectangle, it is different. So the equation is going to be same. This is the only equation. Don't think 1.3 CNC and 0.4 gamma B. Don't think that. Because this is the equation and the S represents the shape factors. So now let's see. I need to find out the QN. What is the design condition again? Q should be is equals to QS. Then you know that Q is nothing but QNU by factor of safety plus gamma D. Take this gamma D to here. Then net pressure is equals to net ultimate by factor of safety. Yes. Now find out the net ultimate bearing capacity for this. QU is equals to, please substitute the values. How to find out the shape factors, sir? They have given, sir. How do we know that this condition is for Meyerhof, sir? After asking this much also, after saying this much also, you are asking same thing, sir. When they give the factors, that is going to be the Meyerhof. Now, look, this condition, gamma D NQ, you know the equation. Let me write down the equation again. Gamma D NQ into SQ into IQ into DQ plus 0.5 gamma B dash N gamma into S gamma into I gamma into D gamma. So please find out the QU value. What is gamma value? Gamma is 18 into D value 1 into NQ 33.3 and SQ, sir. What is SQ, sir, here? Sir, FQS means shape factor. FQS means shape factor SQ, and this is going to be S gamma. See, they have given SQ and S gamma as 1.3 and 4, DQ and D gamma as 1.113, IQ and I gamma. So what is now SQ 1.314, IQ 0.444 into DQ. Where is DQ? 1.113 plus 0.5 into 18 into, what is B dash we got? 1.7 into N gamma 37.16 into S gamma 1.314 into I gamma 0.002. Sorry, 0.02 into last one D gamma 1.113. So please find out this value. If you do anyways small mistake, gone, you will be out of coverage area. This is GATE 2014 question. This is a GATE 2014 question, mind it. 1.314 into 0.444 into 1.113 plus 0.5 into 18 into 1.7 into 37.16 into 1.314 into 0.02 into 1.113. So this is 33, right? Where is this NQ? I did not apply the NQ here. Yes, that's why. $18 into 1 into NQ is how much? 33.3. So what is this value, please? So what happens if we cheat in gate? Simply gate will cheat you. Sir, here can't we find out directly QNU by NQ minus 1 gamma D? No, Nana, because see, this is entire factors, right? This is entire factor. So you cannot directly write NQ minus 1. That's the reason why I have to find it directly. So please tell me this value. 18 into 33.3 into 1.314 into 0.444 into 1.113 plus 0.5 into 18 into 1.7 into 37.16 into 1.314 into 0.02 into 1.113. So I hope the value is going to be 405.84 kilopascals. Yes. Then the net ultimate bearing capacity is nothing but QU minus gamma D, 405.84 minus gamma D as 18 into 1. So 387.845 kilopascals. So now net pressure is nothing but net ultimate bearing capacity by factor of safety. Net pressure is nothing but net ultimate by factor of safety. And what is this net pressure, sir? Net load by area. Keep that in your mind. Somebody has asked, sir, what area we have to use? Keep that in your mind. This is eccentrically loaded. Yes or no? When I say eccentrically loaded, the B becomes B dash, L becomes L dash. So what is this area over here? The area is no more B into L. The area is going to be B dash into L dash is equals to QNU by factor of safety. So QN is nothing but, what is QNU? 387.845 by, what is the factor of safety I have given? 3 into B dash 1.7 into 2. So please find out the net load. $439.56 kilonewtons. This is the answer. And the range of the answer given is, range they mentioned is 438 to 442 kilonewtons. This was a previous gate question. The previous gate question is a gate 2014 question. This is a previous gate 2014 question. Sir, though it's a two-way SNCD or one-way SNCD, we are using same formula. Sir, there is a difference, sir. You see this one, sir. The length, sir. Finally, I am applying the length also, sir. If it's a two-way SNCD, then length is also going to be 1.7 meters, right? If it's a two-way SNCD, then the length is also going to be 1.7 meters. Then here it should be 1.7. So, so for this, there is no shortcut because the equation is there. You have to apply that. And if these type of questions have been occurred in GATE, you better skip it to the end. You do it at the end. You don't do this type of questions at the starting itself. And now I'm going to tell you one more thing here. Look, in examination, how to start the questions. How to start the questions? Look, most of the students are due to their habituation and how we go like a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like that. So most of the students would be habituated towards like solving the questions in a systematic manner, 1, 2, 3. But in the GATE examination, instead of systematic manner, it requires a smart way. The smart way is, first of all, you try to solve all the easiest questions, which means I told you already, in a given paper, in an examination paper, 33% of the questions are going to be done by taking half a minute, which means out of 65 questions, 20 to 21 questions are going to be do it just by seeing the question or just by solving those minor formulas, you can keep those answers. So, my dear students, first you need to focus on one thing. While you are solving the GATE examination paper, you don't need to go for 1, 2, 3, 4 like that. You see the question number 1. If you feel that is easy, do it. Sir, second question is going to be too much lengthy, skip it. Go to the next third question. If it is going to be easy, do it. Next fourth question, lengthy. Fifth question, lengthy. Sixth question, lengthy. Up to 10th question, it was lengthy. Fine, let it be. 11th question is easy, do it. 12th question is easy, do it. So, first, you need to build up your confidence in the examination hall. For example, as you know, as these are random questions comes into the existence, right? Out of 65 questions, the first question of mine will be 10th question for someone. For example, if I got the first question itself is a very difficult question. Let's say this is the type of question I got in the first question itself. Then if I solve the question number 1 itself by this question, I know this is a difficult topic and I have not been habituated with the examination yet. And that is the first question. With the fear I am going to face and with the scare in my mind, with the tears in my eyes, I am not going to solve that question. And moreover that, it not only kills your confidence, but also it kills the next time for the next questions. Because if you are not going to be get the final answer, you will be end up with spending more than 5 minutes for this question. So if you start these type of questions with the examination, you last 5 minutes and you are not going to be get an answer. So that will be more frustrated for you. But if you see the other side, in the 5 minutes of the span, you can solve 4 to 5 questions, easiest questions, right? See, my dear students, if you want to be a topper, though you know all the subject, you have to be in a smartest way. In the first 30 to 40 minutes, at any cost, you need to attempt all the easiest questions. 20 to 25 questions would be the easiest questions. So in the first half an hour to 45 minutes, you have to solve this, which means within first half an hour, you are going to solve 30% of the total paper. And think about that, how much confidence it will boost on you. Not only that, whatever the test series you do also, means you have to cultivate this procedure. Whatever the test series you do also, first you check out the easiest question. Okay, this question is easy. Yes, I can solve it. Immediately. Whether it is 1 mark or 2 mark, doesn't matter for you. Because in GATE, there are 65 questions. That is the only matter for you. So they asked load carrying capacity, why not Q, sir? Sir, they mentioned clearly in kilonewtons, sir, and there is a net safe load carrying capacity, and that too in terms of the kilonewtons. And what is the net safe load carrying capacity? What is a net safe load? Net safe load means QNS, right? That QNS is nothing but QN. So these are the questions regarding to the classroom. And now let's come to the ESC. You see here, a strip footing, So strip footing 2 meters in width with its base at the depth of 1.5. So width is going to be 2 meters. Depth is going to be 1.5 meter. Rested on a saturated clay. Gamma sand is going to be 20 kilonewton per meter cube. Natural water table is at depth of 1 meter below the ground level. Stop your questions and listen to here. This is depth of 1.5 meter and this is width of 2 meter and there is a water table at a depth of 1 meter. This is 1 meter and this is going to be 0.5 meters. Okay. So water table is in which zone? It's in the above the footing and below the ground level. And you know that above the footing gamma, below the footing gamma sand. So now they are asking the ultimate bearing capacity of the footing. They are asking ultimate bearing capacity of the footing. Strip footing, na? This is a strip footing. CNC plus gamma D NQ means, you see, CNC plus, you observe over here, as there is a water table, up to water table, this is surcharge, right? Gamma into 1 plus below water table, gamma dash into 0.5. I have given you this, yes or no? Plus NQ plus 0.5 below water table means below the footing is going to be entirely submerged. Gamma dash B into N gamma. Now they have mentioned CU0, CU and C dash are fine. Now which one I have to use, sir? Listen, this is just to fool you. This is just to fool you. Did they mention any phi value? See, did they mention any phi dash value as 20 degrees? Yes. But did they mention any NC, NQ, N gamma dash? No. As NC, NQ, N gamma for phi dash is equals to 20 degrees is not mentioned. This is just to make you to feel worry. Arey sir, they have given CU and they have given C dash. Which one I have to use? See, the examiner, I want to test your brain. They have given phi dash and they did not mention that. Don't use that. Don't use that. And use CU 40 kilonewton per meter square and phi u is equals to 0 degrees. So when you know the CU, phi u 0 degrees, then NC, they are saying take the relevant NC as 5.14. What is the meaning of relevant NC as 5.14? Are you going to take that CU value or C dash value? 5.14. NQ is equals to 1. N gamma is equals to 0. Yes. So this NC is going to be 5.14. So don't go for the C dash and phi dash. You go for the CU phi u because they mentioned there is no NC, NQ, N gamma value. Now if you substitute, the N gamma is equals to 0, NQ is equals to 1, NC 5.14. So QU is equals to 40 into 5.14 plus, as I did not mention gamma, assume gamma is equals to gamma sand and gamma W as 10 kilonewton per meter cube because we have whatever this value is there, right? We have the options. So with the options we can find. So gamma is how much? 20 into 1 plus gamma dash 10 into 0.5 into 1. So C 45 200 and this is going to be like 51.4 into 4. What is this value? So 4 4 16, 4 5s, 4 1s are 4, 5 and 5 4s 20. So 205.6 plus 20 into 1 20 plus 10 into 0.5 5. Yes or no? 25. What is this value? 230.6 kilonewton per meter square. 231. Nearest value is going to be, what is the nearest value? I did not use any calculator now. I just solved this one. I did not use any calculator. I got the value as a 231. So I hope the point that you need to worry over here is they mentioned the C dash and phi dash. So you don't need to worry as they did not give you the NC and NQ. Sir, what if they mentioned us phi dash, NQ, N gamma, NC, NQ, N gamma, sir? Then they will mention you. Go back to the 13th chapter. If it is an undrained condition, then Cu, phi u. If it is a drained condition, then C dash, phi dash. What is the mean by undrained condition? When the load is applied immediately. So immediately after construction, if they ask Cu, phi u. And at the end of the construction, if they ask drained, please remember the 13th chapter. If the loading rate is going to be quick, undrained condition, so if they ask immediately Cu, phi u. And if the loading condition is going to be slow, then the water will dissipate. There is a drained condition, C dash, phi dash. Means when they give the NC, NQ, N gamma dash for phi dash also. I hope you understood. Okay, fine. So if they mention that, they will mention you immediate loading, or if the loading is going to be, means if the shear stress is going to be develops rapidly and drained, slowly drained. No. You see, consider the following statements as a suggestive of the bearing capacity of the soil. So they have mentioned this ESC 2017. So they mentioned that consider the following statements as suggestive of the bearing capacity of the soil. The maximum net loading intensity at which neither the soil fails in shear nor there is an excessive settlement. See, bearing capacity represents shear failure. Bearing capacity represents shear failure, not the settlement failure. You represent, you remember, so what is the bearing capacity without any shear failure? But this represents a fails in a shear, not in excessive settlement. This is a allowable net allowable bearing capacity. This is net allowable bearing capacity. The definition is going to be, what is the net allowable bearing capacity? The pressure at which soil cannot be failed without shear and without any excessive settlement. Now, the maximum net pressure which the soil can carry without any shear pressure, means the maximum net pressure which the soil can carry without any shear failure. Without any shear failure, this is going to be net ultimate bearing capacity. You please go through that. QNU. What is the QNU? The maximum net pressure that a soil can carry without any shear failure. Okay. And the net ultimate bearing capacity of the soil divided by factor of safety. Net ultimate by factor of safety is going to be net safe. See, the meaning of the bearing capacity means maximum pressure that a soil can bear without any shear failure. This is the second one. But the first one represents excessive settlement. No. Third one represents that is not maximum, that's a safe. That's a factor of safety. So answer is going to be 2 only. Answer is going to be 2 only. Okay. Now let's go for the next one. Yes. See this question. Ultimate bearing capacity of a footing on sand increases with increase in the width. Sand means C is equals to 0. Then cohesion effect gone. Then gamma D NQ plus 0.5 gamma B and gamma. Okay. You see this B. So the ultimate bearing capacity of a footing on sandy soil Q is going to be increases with increase in the width. As B increases, then the Q is also going to be increases. So statement number 1 is going to be true. The settlement of the footing on the sand increases with increase in the width. Yes. So more the width, more pressure bulb and more settlement. Yesterday also I discussed this topic. Yes. The increase in the width in the case of the sandy soil, that's true. That too in the case of the sandy soil, keep that in your mind. In the case of the sandy soil, so the settlement of footing on sand increases with increase in the width. The more the width, the more the pressure bulb goes. So I can show you some figures also. Yesterday we discussed, right? Yes. The more the larger the footing, more the pressure bulb, more the settlement. So both 1 and 2 are going to be correct. Answer is B. Tell the same question by replacing sand and clay. Yes. See, in the case of the sand, if I replace with the clay, the ultimate bearing capacity of footing on clay is independent on the width of footing. So now you see, I have explained that question also somewhere. The ultimate bearing capacity of footing on the clay means the width is going to be 0. N gamma is 0, na? N gamma 0 means width effect is going to be 0. So the ultimate bearing capacity remains same in clay, but increases in sand. No. Consider the following statements. Criteria for selecting for satisfactory performance of the footings are. What is the general criteria? What is the general criteria? The general criteria is going to be the footing should not fail by excessive settlement. Soil supporting the footing must be safe against shear failure. Footing must not settle more than the specified value. What is the meaning of that? Please go. I have explained in the starting. His general requirement is no shear failure, no excessive settlement. Settlement should be in permissible limit. So answer 1 and 2. These are not the considerations. These are the assumptions. Footing must be rigid. Footing can be smooth also. Footing should be above the water table. No, water table can be above the footing also. So these are the two considerations. The answer is going to be 1 and 2. Answer B. In which of the following zones is a logarithmic spiral shape of failure surface? See, below the footing, if you remember, this is linear and this is going to be logarithmic spiral, and then this is going to be the failure. Yes. This is zone 1, this is zone 2, this is zone 3. Zone 2 shape is logarithmic spiral, which means which zone? Radial shear zone. The shape, I'll just show you. Whatever the shape is there, right? The zone 2 shape, this shape is going to be logarithmic spiral. That's not circular or elliptic, that's a logarithmic spiral. Specified values, I'll tell you what is the meaning of specified values. I'll tell you, wait. Geometry shape is going to be linear. Now, I hope you can solve these questions. So I'll be giving as a homework for this. I'll share this slide for you. Now, this is one of the very good question in a GATE question. Listen to this question. So, for a strip footing and a saturated, see, in the case of GATE, I take the questions which you cannot understand it in one sense. So that's the reason why I take a typical type of questions. See, I take a questions which are not going to be done by you directly. For the strip footing on a saturated clay, which means Cu is equals to there, phi u is equals to 0. This is a semicircular failure surface. Remember, semicircular failure surface means see, what is this? This is going to be width as b, and what is this width? This is going to be 2b. So now this is going to be 2b, and here it is going to be b. Now, if you observe the bearing capacity, what is this bearing capacity over here? Qu. So here Qu is going to be bearing capacity, ultimate bearing capacity. See, if you observe in the given figure, let me take this as a ground level. You see the slip surface, this is a semicircle. If it is a semicircle, then this must be center, right? And what is the width I have mentioned, means the radius is going to be b, right? And whatever, this is nothing but I have given you this as a 2b. So let's take point C as a center, because as it is a semicircle, keep that in your mind. As it is a semicircle, then this is going to be the diameter 2b, then the radius r is equals to b, diameter is equals to 2b. Now let's take a rotation. Moment about C. See, you know this is going to be Qu, yes, but is it a loaded area or uniformly distributed? Means is it a loaded area or a point loaded area? So now I can remove all this. I can convert this loaded area into, you know that ultimate is nothing but whatever the load, ultimate load by area. Yes or no? So what is the area over here? This is a strip footing, na? B into 1. Then ultimate load is nothing but Qu into B. So whatever the ultimate load is going to be acts exactly at the center. Whatever the ultimate load is going to be acts exactly at the center. Because you know that when you convert the loaded area into point load, that will act at the center. So what is this ultimate load? Qu into B. And this will act at a width of, means what is this lever arm? B by 2. So now come on, my dear, you please tell me. You see, due to this load, there is a shearing, right? Due to this load, there is a shearing. What is the resisting moment or driving moment over here? Tell me the moments. Have you remembered the moments or not? Moment about C. So the moment about C is going to be due to ultimate load Qu into B by 2, which means Qu into B by 2. Now, there is a shear resistance along the slip surface. Shear resistance along slip surface. So this is going to be driving moment. And shear resistance is going to be, look, you know that, I hope you remember resisting moment MR, resisting moment is equals to resisting force into perpendicular distance. See, with respect to center, you take anywhere, what is radius? The radius is going to be B, because this is semicircle, right? So with C, which is nothing but R is equals to B. So FR into R. Then what is the resisting force? Shear strength into length of arc into R. Now, what is length of arc? R theta into pi by degrees. So pi by 180 degrees. Semicircle, right? Mean is theta is equals to 180 degrees. So R into 180 into pi by 180, which is going to be R pi, And moreover that, in the given question, phi u is equals to 0. As phi u is equals to 0 degrees, then S is equals to Cu. As phi u is equals to 0 degrees, then S is equals to C. So now, my dear student, the resisting moment is nothing but Cu into R pi into R. So, yet failure, factor of safety is equals to 1. Resisting moment is equals to driving moment. See, simply I am doing one thing. I am applying basic mechanics. What is the moment in this direction? And what is the moment in this direction? So with respect to center, what is the moment? Driving moment. And what is the resisting moment? So what is MR? Cu into R pi into R. Driving moment. Q into B by 2. And you know that R is equals to B. Yes or no? So Cu into pi into B square is equals to Q by 2. B square will get cancelled. Then Qu is equals to 2 pi Cu. That's it. Qu is equals to 2 pi Cu. Actually, you know what? Why I have discussed this thing is, if it is going to be the earlier surface is there or not, logarithmic spiral, and there also the analysis is going to be the same way. So there it is going to be 5.14 or 5.7 Cu, but this is not a logarithmic spiral. This is semicircle. So the answer is going to be 2 pi Cu. Most of the students, they'll definitely go for the 5.7 Cu or 5.14 Cu, because RSR Cu 5U0, then he is going to be definitely the clay soil. For the clay soil, ultimate bearing capacity is going to be 5.7 C. No. Please have a look. Just look over this, that's it. Whatever the rotations, you have to look over the rotations, that's it. There is no logic, Nana. The logic is moment, resisting moment and driving moment are going to be same. What is the resisting moment? Cohesion, means whatever the shear strength acting along the base. What is the driving moment? Due to the load, point load, Qu. Please observe. Any logic? The logic is, this is the logic. And you know what is resisting moment, and you know what is driving moment. See, I have given you for the sake of procedure. I have given you for the sake of procedure. If I don't write like this, most of the students won't understand. So did you attend a GATE examination twice? No, I attended only once. Okay, now let's see the next question. Yeah, this is also a very good question. Look, 4 columns of a building are to be located with a plot size within a plot size of 10 meter by 10 meter. So what is the plot size? Means the total area 10 meter by 10 meter. So area is equals to 100 meter square. So this is a total plot. The total plot is going to be 10 meters by 10 meters. This is a total plot. So here we have a plot size of 100 meter square. Now, now the expected load, see 4 columns you are going to construct. Look, you want to construct 4 columns. You want to construct 4 columns. Let's take column number 1, column number 2, column number 3, and column number 4. See, I am not drawing a footing. I am drawing the columns. Okay. So 4 columns are there. 1, 2, 3, 4. So the load from each column is going to be load from each column is how much? 4,000 kilonewtons. Okay, fine. Allowable bearing capacity is going to be 100 kilopascals. The allowable bearing means QS. What is the safe bearing capacity? Allowable means safe. Net allowable means net safe. Allowable is going to be 100 kilonewton per meter square. You know that for safe design, Q should be less than or equals to QS. Yes or no? So now let's see what they're asking is the type of foundation that are required. Let me go with the options. See, I have given the plot area and I have given the load from each column. And now if I go for the isolated footing, so if I go for isolated footing, then what is the gross load? Gross pressure is nothing but load by area of footing. Yes or no? Load by area of a footing. So now, if I go for the gross load, you know that, please observe, this is going to be QS. This is going to be QS. So now, for safe design, we have to go for Q less than or equals to QS. Now, you know, each column is going to be carrying a load of 4,000. Then 4,000 by area of footing is equals to how much should be? It should not be exceed 100 kilonewton per meter square. Yes or no? See, whatever the pressure coming from the isolated footing should not exceed the 100 kilonewton per meter square. And if this is the case, then what is the area of footing? What is the area for one footing? So 4,000 by 100, which is going to be 40 meters square. Then what is the total area of footings? What is the total area? See, for one single footing, this is going to be 40 meters square, 40 meters square, and 40 meters square, and 40 meters square. So then what is the total area of footings? 4 into 40. What is the total area of footing? 160 meters square, Nana. See, first what I am telling you is, I gave you the safe bearing capacity, how much given as 100. Now, if I construct a columns, then each column should take a load of how much? Each column should take a load of how much? 4,000 kilonewtons. Okay. Now, if you go for the 4,000 kilonewtons, then for one footing, what is the area of the isolated footing? The area of the isolated footing you have to provide 40 meters square for no failure, for the safe design. For the safe design, this is safe design or not? For the safe design, how much area of one footing required? 40. And what is the total area of footings? 160. But what is the total area of the plan? 100 only. So area of footing is more than area of plot. So which means not suitable. So my dear students, how come I fix whether I want to go for isolated or raft or pile foundation? You please observe over here. So if I go for this area of plot not suitable, then definitely it is not going to be suitable, right? So isolated foundation is not going to be suitable. I hope you understood. Then similarly, let's go for the raft foundation. If I go for the raft, if I go for the raft foundation, what is mean by raft foundation? What is mean by raft foundation? See, raft foundation means the total footing, all the columns will be in a single footing. 1, 2, 3, 4. Okay. What is the plan area? What is the plan area? The plan area is going to be 10 into 10, which is going to be 100 meter square. Then total load is equals to 4 into 4,000, 16,000 kilonewtons. Then what is the gross pressure over here? Q by area of plot. See, Q by area of plot. I'm checking. Look, if I take a raft, then the entire 10 meters by 10 meters should be act as a raft. So what is the area of raft? What is the area of raft? The area of raft is equals to area of the plot. So then 16,000 by 100. What is this value? 160 kilonewton per meter square. Look, my dear student, if I apply the raft foundation, then what is the gross pressure acting at the base of the raft foundation? What is the gross pressure acting at the base of the raft foundation? 160. But what is the safe pressure we know? The safe pressure is just 100 kilopascals. So as Q is greater than the safe bearing capacity, not suitable, because we know we need to make sure that load, whatever the gross pressure for safe design, Q is going to be less than or equals to QS. So you please observe. First I find out the gross pressure due to the raft, 160. Is it more than 100 or less than 100? More than 100. So as the gross pressure is more than the safe bearing capacity of the soil, it is not going to be suitable. Remember, raft is not suitable. If isolated and raft are not suitable, combined is also not going to be suitable. If isolated and raft is not going to be suitable, combined is also not going to be suitable. So the suitable foundation is going to be pile foundation. If isolated and raft foundation are not suitable, then combined also not suitable. So the answer is going to be whom? The answer is going to be answer as a C. So this is how we have to check what type of foundation. See, if I have a plot size of 10 by 10 and I am going to calculate, see how you find out this 4,000, sir, from your RCC. From your structure analysis, I got to know 4000. Then I got to know these values. We don't need to fire, we don't need to go for the pile foundation check because you don't know that what is the meaning of pile foundations and all, but you can go for the pile foundation. Go for pile foundation. Now, okay, fine. I am giving this as a try it now. Try it now. So I'm giving you break. It's 11:08, 11:08, and I have a break up to 20 minutes. Means 11:30. Come by 11:30. So now this is a previous gate 2019. I hope you can solve this question. Solve it. Try to solve this question. Try to solve this question. So those who wants to take a screenshot, you can have a screenshot here. And this is the question I'm asking you to solve. So So I hope you solve this question over here. So the people who have solved, just I'll give the details. So here, solution given square footing, width is going to be 4 meters, place depth is going to be 1 meter, and the dry unit weight of the sand is given as 15 kilonewton per meter cube. The footing has an ultimate bearing capacity as 600 kilopascals. So I hope you got these answers. If you have got these answers, then it's fine. So the answers would be NQ is equals to 10. And first you have to apply this QU value and you need to find out the NQ value. Then you have to find out the same equation for the next question also. I hope everybody would have solved this one. If not, you try it again in your home. But now let's see this question. This question seems to be too much lengthy, but there is nothing in this question. Actually, for this question are not there here. In the GATE also, in GATE 2013, they have given, they have awarded some marks. Whoever has attempted this question, they have been awarded marks. Okay. So now, a multi-story building with a basement is to be constructed. So there is a multi-story building with a basement. So you know that this is nothing but basement slab, which is nothing but a raft. The top 4 meters consists of loose silt, and below which dense sand is going to be present up to great depth. Ground water table is at the surface. So the water table is at the surface. So you have to apply the water table correction, which means the entire soil is under submergence. So given depth of foundation as 4 meters, width of foundation as 6 meters, and apart from that, for dense sand, saturated unit weight they have given gamma sat 20, and they have given the bearing capacity factors for this NQ and N gamma. And apart from that, there is a loose silt. So now here gamma sat is equals to 18, and they have given some NQ and N gamma also. See, in this question, I am the examiner. The examiner tries to fool you by giving you the NQ and N gamma of a silt and NQ and N gamma of the sand. So, my dear students, now you may be in a tricky situation. So, which NQ, N gamma should be used? Should I go for loose silt? Should I go for dense sand? Mind it, here, D is going to be less than B. Yes or no? Which means shallow foundation. Shallow foundation. So according to Terzaghi, soil above foundation is taken as surcharge only by neglecting its resistance. So we know that soil above the foundation is taken as surcharge only by neglecting its resistance. So soil properties above foundation will not used. So if you can understand this point, look, As it is going to be shallow foundation, according to the Terzaghi, the soil above the foundation is just acts like a surcharge. And what is the surcharge over here? Gamma into D. And as the water table is over here, gamma dash into D. That's it. Gamma dash into D. And as the side resistance is going to be neglected, you are not going to be using any properties above the soil, means above the base of foundation. So don't use NQ, N gamma of loose silt. So NQ, N gamma values of loose silt are not used. Then what is the question they have given, sir? The effective cohesion is going to be 0. Unit weight of water is going to be C10. So for dense sand, effective cohesion is going to be 0. Gamma sat is equals to, for dense sand, gamma sat as 20. NQ is going to be given as a 40 and N gamma as 45. So now the footing is going to be what type of footing over here? So if you observe, there is going to be a strip footing. They did not mention anything, right? So as they did not mention anything, it's a strip footing. QU is equals to CNC plus gamma DNQ plus 0.5 gamma B N gamma. CNC plus gamma DNQ plus 0.5 gamma B N gamma. And keep that in your mind. Now, yes, as the soil is going to be completely submerged under water, gamma becomes gamma dash. Yes, so this is going to be C0, but this is going to be silt and this is going to be sand. So now the ultimate bearing capacity, what I'm asking you is the net safe bearing capacity. First you find out the ultimate bearing capacity. The ultimate bearing capacity is gamma dash of silt. What is it for loose silt? Gamma sat 18. 18 minus 10 into 4 into which is 40 plus 0.5 into 20 minus 10 into B value 6 into 45. Please find out this value. 8 into 4 into 40 plus 0.5 into 10 into 6 into 45. So which is going to be 2630 kilopascals, and safe means net ultimate by factor of safety plus gamma D. So net ultimate minus gamma dash into D by factor of safety plus gamma dash into D. Why I am taking gamma dash into D? Whose loose silt is used? See, this is a surcharge, right? The surcharge means gamma dash, whatever the loose silt unit weight into D. But NQ and N gamma are not going to be useful. NQ and N gamma is going to be useful for the sand only. So now 2630 minus 18 minus 10 into directly I can write 8 into 4 by what is the factor of safety I have given? The factor of safety is going to be 3 plus 8 into 4. By 3, it force. They're asking net safe. Okay, sorry. This is net safe they're asking. So as they're asking net safe, net safe. So answer is going to be 866. 866 kilopascals. The actual answer is 866 kilopascals. See, the only point that you need to look over here is you know how to solve this one. But the only point that you need to look over here is above there is a loose silt and below there is a sand. So above has properties and below has properties. But mind it, you need to apply the above soil as a surcharge at the base of foundation. So NQ and N gamma of above soil is not going to be used. As there is no option here, answer is not given. A 2 marks question tha. This is total of 4 marks. Linked answer type 13 and 14. Similarly, look, the foundation slab is subject to vertical downward stress, which is equals to net safe bearing capacity. The foundation is going to be subjected to downward stress. So in that B, downward stress net pressure, which is equals to net safe bearing capacity. What is net safe bearing capacity we got? 866 kilopascals. So net safe bearing capacity derived in the above question. Using influence factor I as 2 and neglecting the embedment depth and rigidity corrections. So you don't need to do any rigidity corrections. You don't need to do any rigidity corrections. And the immediate settlement of denser sand should be, if you remember the immediate settlement, Qn by E into B into 1 minus mu square into I. Have you remember this? Where Qn is pressure from external load. So now they given the Poisson's ratio as 60 and Poisson's ratio as 0.3 and Young's model as 60 into 10 to the power of 3. Kilonewton per meter square and Poisson's ratio as 0.3 and IF as 0. IFR, I influence factor as 2. So this is the value. Now you please substitute. SI is equals to 866 by 60 into 10 power of 3 into, what is the B value mentioned? B is equals to 6 meters. 1 minus 0.3 square into I value as 2. The immediate settlement. What is the immediate settlement, please? So which is going to be 0.1576 mm. So the meters. Answer is going to be 157.6 mm. This is the answer. That should be who said jumbo equation, right? Jumbo. Sir, chapter అయిపోద్ది. Does అయిపోద్ది. I'll give you one point over here. If you observe, I hope you understood this. Sir, if layered deposit is present below foundation in shear zone. If layered deposit is going to be present below foundation in the shear zone. So below foundation in the case of the shear zone is going to be like now. For example, if this is the foundation, so this is a ground level. Let's take this is a soil 1 having a C and 5, and okay, there is a soil 2. This is the base of the foundation or not? This is the base of the foundation. See, if the soil above the foundation is a different soil, we don't take those properties. Now soil 2, C2, phi 2. If this is width, let's take up to width B, and this is going to be D. If there is a layer deposit something like this, now this one has some n values and this one has some other n values. So then what we have to do is we have to take the average, weighted average soil properties should take as weighted average, which means if this is going to be a depth of x1, if this is going to be a depth of x2, if this is going to be a depth of x1 and if this is going to be depth of x2, then what you have to do here is C average is equals to C1 x1 plus C2 x2 by x1 plus x2. C1 x1 plus C2 x2, that is a weighted average. Look, if the soil, if the layer deposit is present below the foundation in shear zone with the different properties, and phi average is equals to phi 1 x1 plus phi 2 x2 by x1 plus x2. Then what is the ultimate bearing capacity, sir? Normally the equation is going to be CNC plus gamma DNQ plus 0.5 gamma B and gamma. Yes or no? 0.5 gamma B and gamma. Now, if this is going to be C average, then NC double dash, NQ double dash, and N gamma double dash. Where NC double dash, NQ double dash, N gamma double dash depends on phi average. So this is advanced condition. If they ask you this also, that I am telling you, if a layer deposit is present below the foundation shear zone, soil property should take as a weighted average technique. The weighted average means, you know, the centroid formula there, A1x1 plus A2x2 by total area. So similarly, in the case of permeability also, when flow is parallel to bedding planes, weighted average, K1Z1 plus K2Z2 by total depth. So those are nothing but the weighted average techniques. So if there is a single soil, CNC. But if there are multiple soils, you have to take the weighted average and then only you have to calculate this. I hope Mr. Limbasia, you got your answer. So now that's all with this. And the last topic in this chapter. Today we were focused more over solving the problems in our previous GATE and IES. I hope You understood well? So now let's see the plate load test. So the last test in this chapter is a plate load test. So you want me to go for the 59th page. Yes, is there? And mind it, these values will be given in the examination. They will give you the examination. These values will be given in the examination, so don't worry. So let me go, let me solve no answers provided. Now let's come to the plate load test. See, listen to this. Stop your thinking and listen to me. Yeah. So see, so far and so good. We have discussed a lot of theories like Rankin's theory, Terzaghi's theory, Skempton's theory, Meyerhof theory, and we have done a lot of corrections, water table correction, and we have done for shape factors, inclination, and eccentricity, all these things. But all these are analytical procedures to determine the ultimate bearing capacity. These are the analytical procedures to determine the ultimate bearing capacity. But how we are going to find out the same ultimate bearing capacity? How we are going to find out the same ultimate bearing capacity? By using a test, means experimental procedure. See, there are three types of tests: standard penetration test, cone penetration test, and a plate load test. So we will be seeing the SPT, standard penetration test, and CPT, cone penetration test, in soil exploration, which is the next chapter, means chapter number 18. So means after pile foundation. But in this chapter, I am going to discuss about the plate load test. And keep in your mind, whatever the plate load test in this chapter and the pile load test in the next chapter, in pile foundations, we are going to see. So in the pile load test, we have in pile load test also, in pile foundations, there is a pile load test that is similar to the plate load test only. I'm just showing you a figure, a description of the plate load test. But first of all, let's see what is the purpose of this plate load test. So now, if you observe, plate load test. Look, this plate load test, we are going to determine initially. See, in transportation engineering also, you know the test of plate load test. There you are going to determine the modulus of subgrade reaction, means whatever the reaction made by the subgrade, that you will be seeing in the chapter number residue pavements in transportation engineering. I hope you might heard about the residue pavements. There you use the same test of plate load test to determine the modulus of subgrade reaction K. But in this case, here we are going to discuss about to determine ultimate load carrying capacity, which is nothing but QU, which is a ultimate bearing capacity of the soil. allowable bearing pressure for permissible settlement, for a permissible settlement and settlement of foundation. So we are going to determine all these things by the means of a plate load test. First of all, why we are going to conduct the plate load test? What is the meaning of ultimate bearing capacity? You know, the ultimate bearing capacity, if I am a soil, the maximum gross pressure that I can take without any shear failure. For example, if you want to find out the ultimate bearing capacity of a soil mass, are you going to construct the actual structure and check the soil mass? No, right? Are you going to construct the real footing and then you apply the load so that at some point of time soil will fail? When the soil will fail, the entire footing is also going to be failed, right? So instead of doing the footing, we are going to take a plate. Instead of doing the footing, we are going to take a plate. You see, you observe. Yeah. See, if this is a ground level and if this is a foundation, if this is a ground level and if this is a foundation, generally what we do is we do construct the structure, right? So when we do construct the structure, you know that we are going to construct the foundation first, and then we are going to construct the footing. Yes. So this is the actual footing, and whatever the pressure that is going to be passes due to the load and self weight, this is nothing but the gross pressure, and the soil is going to be offers a maximum resistance as a QU. But in order to find out this QU, are you going to construct the real-time structure? So whatever this is nothing but, let's take a width of the foundation. Whatever this is nothing but the width of the foundation. So are you going to construct exactly, means are you going to construct the actual foundation and check the variables? No. What we do is we resemble this to a plate. We resemble this to a plate, and that plate may be square plate or rectangular plate. That plate may be a square plate or rectangular plate. So if you see that plate, that plate may be a square plate. So if you observe, this is a square plate, or it can be a circular plate also. It can be a circular plate also. So the plate can be either square or circle. This is a circular plate and this is a square plate. And the thickness of the plate, see what we do is instead of constructing the actual footing, we resemble the footing into a plate, and then we conduct the test on the plate, and then we conduct the test on the plate. And this plate, the plate dimensions varies from 30 by 30 centimeters to 75 by 75 centimeters. So the plate dimensions varies from, or I can write like this. The plate dimensions are going to be varies from 30 centimeters to 75 centimeters. 30 by 30 to 75 by 75. 30 by 32, 75 by 75 centimeter. If you take it as a square plate, then if you take this is the width of the plate, and whatever this is nothing but thickness of the plate. TP means thickness of the plate. So the plate dimensions are going to be 30 by 30 centimeters. If it is a square plate, width is going to be 30. If it is a circular plate, then whatever the dia, this is also going to be here. This is going to be width of the plate or dia of the plate. In the case of circle, dia. In the case of the square, side. And you see, whatever this smaller size are going to be useful for the denser soils. Larger size are going to be used for the looser soils. Why, sir? Sir, listen. In the case of denser soil, the bearing capacity of the soil is more. When the capacity is more, then the area of footing required is going to be less. But in the case of the loose soil, if I increase the area, the more the area, load by area, the more the area, the lesser the pressure. When the pressure acting on the soil is going to be less, then the soil is going to be safe. So loose soils will not take more pressure. So we reduce the pressure by increasing the area. And the denser soils are not going to be, denser soils has more capacity. So we don't need to go for higher areas. And irrespective of size, the thickness of plate is 25 mm. The thickness of the plates are going to be 25 mm. So the plate dimensions are going to be 30 by 30 centimeters too. These are the dimensions, plate dimensions are going to be 30 by 30 centimeters to 75 by 75 centimeters. Let me repeat again. Instead of foundation, I resemble the foundation to a plate, whether it may be a square plate or a circular plate, whose dimensions ranges from 30 by 30 to 75 by 75. And in general, 30 means 30 centimeters, 45 centimeters, 60 centimeters, 75 centimeters. These are the plates that we use. And every plate thickness is going to be same. Each and every plate thickness is going to be same, irrespective of the dimension. Every plate thickness is going to be same. So now what we do in this test, sir? What we do in this test is now let's come to the yes. So what we are going to do in this test is now, if you observe, whatever this is nothing but a pit, right? Whatever this is nothing but a pit. First of all, we are going to excavate a trench. We are going to excavate a trench. And whatever this is nothing but the depth of foundation, means where we are going to construct the footing. We just construct the footing, means wherever we want to construct, you please make a trench or an excavation up to the depth of foundation where the actual foundation should be there. And you see, whatever I'm representing here, this is nothing but a plate. Please observe, this is a plate, and I have represented whatever this plate is nothing but the bearing plate. Bearing plate means this is the plate. Bearing plate. So at first, my dear students, first we need to excavate the soil mass up to the actual depth of the foundation. Up to the actual depth of the foundation. And the plate, whichever is going to be used, we are going to keep that plate. This is the plate at the center of the foundation. And keep that in your mind, whatever the trench details is there on this width, is going to be width of the foundation. So point number one, first we excavate the soil mass and we keep the plate. Procedure. Excavate a trench whose width is 5 times of width of plate up to foundation level. Up to foundation level. Point number one, we are going to excavate a trench whose width is going to be 5 times of width of the plate up to excavation level, which means whatever the width of foundation is nothing but 5 times of the width of the plate. So width of foundation to width of plate is equals to 5. It's a metallic plate. Yes, these procedures can be asked in ESC mains. So now, whatever the plate we are going to use, this plate is going to be kept, the metallic plate, whatever this plate. This is the plate. And the plate is going to be kept at the center level. Place the metallic bearing plate at center of trench, and keep that in your mind. If there is a water table, then definitely you have to lower the water table. If water table is located at the base of or at the place of the test, at the place of the plate, it should be lowered below at least 1 meter below footing level. See, the meaning of this one is, if there is a water table located over here, you have to lower it down to at least 1 meter below the footing. So this is original and is going to be lowered. So the point is, if there is a water table located at the place of the test, you have to lower down the water table by at least 1 meter. And if water table is located originally, see, based upon the plate load test, there were n number of previous ESC questions are there. There are lots and lots of questions were there. If you go through the previous ESC, then you can get to know. If water table located originally at a depth of 1 meter below footing, no correction is required. Correction means no lowering is going to be required. No correction is required. So now, first of all, I did not apply it. See, I did not explain you the total part also. Now you see, at first I have been trench and I kept the plate, and if there is a water table. Now you insert a hydraulic jack. This is the hydraulic jack. This hydraulic jack means it pushes the load and it is going to be lifts up also. It pushes the load. So initially, due to this hydraulic jack, the load is going to be transferred to the plate. This will be visible more. Yes. Load is going to be transferred through the plate by means of the hydraulic jack. Initially, a seating pressure of 7 kilonewton per meter square is applied and released after some time. So keep that in your mind. So what is mean by this seating pressure, sir? Sir, this is a base of the soil and this is the plate. Now, if you keep the plate on the base or foundation, the contact between the plate and the foundation must not be the full contact. Yes. So if you just keep the plate on the ground, there might not be the proper contact between the plate and the soil. But now if I press it means then there is a proper contact between the plate and the soil plate. If you just place the plate on the soil, there might not be proper contact between the plate and the soil. But if you press it a little bit, if you apply some pressure, then there is a proper contact, and that pressure is known as a seating pressure. So initially a seating pressure of 7 kilonewton per meter square is applied and released after some time. Then loads are applied. Now we come to here. So this is a steel joist. See, this is enters the mechanism. This is a bricks. This is a steel joist, and this is a hydraulic jack. And over that we are going to use sandbags for the loading. So loads are applied as sandbags in increments, not more than 100 kilopascals. So you are going to apply the load not more than 100 kilopascals, which means, so first you apply some 50, then again you apply one more 50, again one more 50, again one more 50, like that. So these sandbags are going to be applied in the stage 1, first, second, third, fourth. You are going to apply. Now, my dear student, when you apply this load is going to be transferred through whom? The steel joist, and from the steel joist to whom? Hydraulic jack, and from the hydraulic jack to whom? Plate. So from the hydraulic jack to the plate, this load is going to be transferred. When the load is going to be transferred, then this plate starts to settles down. This plate starts to settles down. Now, when the plate is going to be starts to settles down, that is going to be measured by means of the dial gauge. So dial gauge is used to measure settlement. To measure the settlement, we are going to use the dial gauge. So once you know the settlement, see, first you apply the pressure in increment. And now for a given load, you are going to observe the settlements with respect to that time. You are going to observe the settlements with respect to that time. Note down the maximum settlement at which the soil is going to be stopped. So, loads are applied as a sandbags in increments not more than 100 kilopascals. And observe the settlements through dial gauge readings. Now, loading is applied up to settlement reaches 25 mm or at least 10% of width of plate. See, wherever the settlement, you please look over the settlement, see, whatever the settlement when the reaches, see the plate is going to be settled, right? And you need to take the observations, at regular intervals. You need to take the observations at regular intervals. Due to this loading, the pile means the plate is going to be settled or not. And when the plate is going to be settled, note down that settlement and apply the load so that the total plate is going to be settled by 25 mm or at least 10% of the width of the plate, or at least 10% of the width of the plate. So by the time you reach this point, now what we do is, whatever the load you applied, Q, and whatever the settlement, yes, whatever the load you applied Q, first initially let me go with the 50 kilopascals. What is the settlement? 100 kilopascals. What is the settlement? 150, 200, 250, up to the load. Whenever the settlement is going to be reaches at least 10% of the width of the plate. When the plate settles more than 10%, then you stop the test. That is the meaning of this one. So loads are applied as sandbags in increments, not more than 100 kilopascals. You see the increment from 50 to 100, 50, 100 to 150, 50, next 50. So you are going to increase the load not more than 100 kilopascals, and that is going to be applied up to a settlement of 25 mm or at least 10% of the width of the plate. So once we get down the details of this Q and S, now plot the load versus settlement curve. What is the duration between application of the incremental loads? That's what I'm saying. See, for a given load, you observe the settlement, and whenever the rate of settlement is going to be very less, just means we generally take 2 to 4 hours. It depends upon the type of soil mass. Load versus settlement curve we are going to apply. Now, Q on x-axis, S on y-axis. So now if I plot the graph, if I get the graph like this, have you remembered this type of graph earlier? Have remembered the type of graphs earlier? So if you remember this, yeah, if you remember this, so I have showed you this type of graphs, right? If there is a sudden failure point, what is the type of failure you are going to see? General shear failure. General shear failure. You know, if the failure occurs suddenly, soil below footing has a less compression and soil shear more insides. So if there is a sudden failure, then that is known as a general shear failure. So now, after plotting load versus settlement curve, if I got this point, then this type of failure is known as a general shear failure. And whatever this point, this is known as a failure point. And you know that at a failure, whatever the gross pressure you applied is nothing but the ultimate bearing capacity. So means this is going to be ultimate bearing capacity, and this is the settlement corresponding to the failure. That is a settlement corresponding to the failure. This is for general shear failure. And in the case of the local shear failure, this is Q and here is going to be S. So now, in the case of the local shear failure, you know that failure is going to be plain, but there is no sudden failure. You cannot see the sudden failure. You cannot see the sudden failure. So as you cannot see the sudden failure, we are going to take this one as in terms of the log scale. Now, let me plot this as a log scale. In the case of the log scale, for the same graph, what we are going to do is we draw two tangents. This is one tangent. This is going to be other tangent. Wherever they are going to be meet, and this point is known as the failure point. So this is the ultimate bearing capacity and this is the settlement. This is known as a tangent, log tangent method. So you plot the graph in the log scale and you draw the tangent from the last point and from the first point. Wherever they are going to meet, that is going to be the failure point. So my entire intention here is to determine the ultimate bearing capacity. So for that ultimate bearing capacity, if it is a general shear failure, then the failure point is going to be predictable point and I can find out the QU from the load settlement curve. But in the case of the local shear failure, the graph is not going to be having a failure points. You see here, there is no failure point. As there is no failure point, what I do is I go with the log scale and then I draw the tangents. This is known as log tangent method. Wherever these tangents are going to be meet, these are nothing but a tangent, Nana. Wherever these tangents are going to be meet, they are going to be the point at which the failure occurs. Because if you observe, whenever there is a failure, there is a sudden change in the slope. This line slope is different. This line slope is going to be different. Yes. So that's why what we got is for local shear failure and for general shear failure. Sir, what about the punching shear failure? I told you punching shear failure is going to be seen in the case of pile foundations, not on the shallow foundations. So I hope you understood. But yes. But whatever the discussion I made, this is going to be QU, and this is going to be means whatever the settlements are ultimate bearing capacity. Have we found for actual footing or for the plate? For actual footing or for the plate? For the plate. So the limitations of this method is number one, QU, S and S are found out under plate, but not under footing. See, whatever the ultimate bearing capacity and settlements are found out under plate, but not under footing. Sir, what is the difference between the plate and footing, sir? Now, you see. Let me take this as a plate width and let me take this as a foundation width. So this is a plate width BP and this is a foundation width BF. F represents the foundation, P represents the plate. And if we draw pressure bulb for the under the plate. This is the pressure bulb, and under the footing this is going to be the pressure bulb. Yes or no? And whatever the depth, this is nothing but the significant depth or not? Significant depth. So what is this? This is going to be pressure bulb, and here it is also going to be pressure bulb. But you tell me, whose pressure bulb is going to be more? Whose pressure bulb is going to be more? Foundation. See, whatever the values I got, the settlement and ultimate bearing capacity, the settlement and ultimate bearing capacity is under the plate, not under the foundation. But actually is going to be foundation, right? So you know that more the width or size, more pressure bulb and more settlement. So which means whatever the settlement I got under plate is not the exact settlement. So I have to do some correction. I have to do some correction. So definitely point number one, I hope you understood. Here we need to do corrections for the ultimate bearing capacity and the settlements. Can we not multiply it by factor of safety? So it by factor of safety, so we can get a QU in terms of foundation. No, you cannot. If the width of plate, yeah, we have to do some corrections. We have to do some corrections. What is so now this is a point number one, and this test is a short duration test. See, you are not going to be do this test for a long period of time. As this test is a short duration test, settlements are immediate settlements. So this test is not appropriate. This test is not appropriate for clayey soils, as primary consolidation settlement requires time. So now, my dear, this is going to be a short duration test. So whatever the settlements I have found over here, those are nothing but immediate settlements. Those are not the primary settlement. Those are the immediate settlement. So this test is not appropriate for the clays. Even if you use clays, you can find out the immediate settlement, but not the primary consolidation settlement. So these are the major two drawbacks, and as these are the drawbacks, we have to do some limits from these limitations. We have to rectify this by means of the corrections. By means of the corrections. And third one, water table should be lowered if it is above or yet place of test. So these are some of the limitations. Now, in order to come across this, means in order to overcome these limitations, we need to do some corrections. Now, those corrections are: corrections. Number one, settlement correction. Number one is going to be settlement correction. Sir, if the footing area is a more, the load gets disturbed over a large area and stress is low. Stress is low, that doesn't mean that settlement is going to be low. Stress is low, that doesn't mean that settlement is going to be low. Settlement, Ms. Nakshatra, settlement depends upon the type of soil also. If the load is less, that doesn't mean that the dense sands and the loose sands both are going to be having same settlement, right? Does plate load test predict accurate value for C5 soils and sandy soils? This is going to be for sandy soils mostly. Okay, fine. Yeah, go to the slide. I have moved this slide. Come on. If you want to take a screenshot, you can take. Now I am going to do the corrections because as a bulb means as a width changes, pressure bulb changes. So I have to do corrections for the ultimate bearing capacity and settlements. I hope. So now coming to the settlement correction. As you know, immediate settlement means Q by E into B into 1 minus mu square into I. In case immediate settlement is going to be Q by E into B into 1 minus mu square into I. Now, my dear student, this settlement is directly proportional to the B value or not? So, first, in the case of clays, the settlement is going to be directly proportional to B. So, whatever the settlement under footing, SF by SP is equals to BF by BP. In simple words, S directly proportional to B, where SF settlement under footing, SP settlement under plate. And similarly, in the case of the sands, if it is sands, SF by SP is equals to BF by BP into BP plus 0.3 by BF plus 0.3 whole square. SF by SP is equals to BF by BP into whole square. See, this is going to be just simply as directly proportional to B, but in the case of the sands, it's not going to be that much simple. So in the case of sands, there is a derivation. You don't require the derivation. Wherever there is a possibility, I say, and you don't need to worry about that. So in the case of the clays, settlement is directly proportional to width. More the width, more the settlement. So these are the equations. Square. Now. Yes. Now coming to the bearing capacity corrections. Second one, bearing capacity correction. See, what is the bearing capacity, ultimate bearing capacity? QU is equals to CNC plus QNQ plus point, see, as it is a square plate, for square plate. Whatever the ultimate bearing capacity for the plate is 1.3 CNC plus Q into 0.4 gamma B and gamma. Just keep it like this. Okay. Now, my dear student, if you see, is there any overburden pressure acting over here? Is there any overburden pressure acting over here? No. This is a trench. And this is the plate BP, and this is the load P. So no overburden pressure over here. There is no overburden pressure, which means no self weight of the soil mass. So surcharge is going to be zero. Surcharge is going to be zero. Now, in the case of clays, now in clays, n gamma is going to be zero. In clays, n gamma is going to be zero means in clays, for the same equation, n gamma is 0. Then Qu is nothing but 1.3 CNC. So in the case of the bearing capacity corrections, first A, clay. Ultimate bearing capacity of clay is independent on width. As ultimate bearing capacity of clay is independent on the width, whatever the ultimate bearing capacity of the foundation, ultimate bearing capacity of the plate, both are going to be same. Because you know that in the case of the clays, you see the ultimate bearing capacity is going to be simply 1.3 CNC, no width at all. But the same equation in sands, C is equals to 0. When C is equals to 0, the ultimate bearing capacity is going to be 0.4 gamma B and gamma, which means Q directly proportional to B. So now the B is in sands, Q directly proportional to B. So QF by QP is nothing but BF by BP. So I hope you understood these conditions. Yes. So these are the corrections that we are going to do. In the case of bearing capacity for clays, Qu is independent of the width. Now for the bearing capacity, I have written the equation first, and as there is no overburden pressure, then I removed the surcharge. As there is no overburden pressure, then I removed the surcharge. And in the case of clay, n gamma 0, when n gamma 0, then Qu is equals to 1.3 CNC, so independent on the width. But in the case of sands, C0, then Qu is equals to 0.4 gamma B and gamma, Q directly proportional to B. And you know that at a failure, Q is equals to Qu. These are the corrections that we are going to do for settlements. For settlements, clays is directly proportional to B. Sands, SF by SP is equals to BF by BP into BP plus 0.3 by BF plus 0.3 whole square. And similarly for the bearing capacity corrections. So these are the corrections. Please have a look once. If you have a look, I will have some So, Mr. Anonymous attendee, boring level is equals to tan 90. Wow. Then your understanding level is going to be cos 90, I think so. Now, so that's about the corrections and this is the limitations. These are the load settlement curve and these are going to be the procedure and this is the plate load test. You please have a look. I'll be giving 2 minutes of time. Pressure bulb itself is a soil, right? Yes, does plate load test fails? Yes. See, whenever the test is going to be fail, or see, when the settlement reaches 25 mm, or the plate is going to be fail, or at least 10% of width of plate, then you are going to stop the loading. The corrections are, in the case of clays, S directly proportional to B. In sands, SF by SP is equals to BF by BP into BP plus 0.3 by BF plus 0.3. See, this is going to be for whole square. Sir, why use sandbags for loading? Sir, you can use anything, but if I use sandbags, that's going to be economical for me. Any permissible limits? Yes, now I'm going to discuss the permissible limits. So now coming to the permissible limits or allowable limits. So as per IS code, Indian Standard, Bureau of Indian Standard codes, there are a lot of codes for the bearing capacity itself, there are some codes. So as per IS code, now at first, differential settlement See, in the case of the differential settlement for sands, there are some values for the differential settlement. I told you that differential settlement means the level difference between the footings. I discussed you earlier itself. In the case of sands, the permissible value is going to be 25 mm. And in the case of clays, the permissible value is going to be 40 mm, which means, so if I go back, I can explain you where is the differential settlements. Yes, you see, this is nothing but a differential settlement or not. The difference between the two footings, that is known as differential settlement. If you construct your structure in the case of the soil mass where there is a differential settlement, if it is a sand, the settlement should not exceed 25 mm. This differential settlement should not exceed 25 mm. Whereas in the case of clays, this differential settlement should not exceed 40 mm. Should not exceed 40 mm. And direct settlement under isolated foundation and raft foundation. Under isolated foundation and raft foundation. See, you know that from the concept of the more the base, more the pressure bulb, more the settlement. Think and say, does isolated footings has a more permissible range or raft footings has more permissible range? Does isolated footings has a more permissible range or does raft has a more permissible range? So raft means the more the width, the more the pressure bulb, the more the settlement. So obviously in the case of the raft foundation, settlements are going to be more, but differential settlements are going to be less. So in raft, though direct settlements are more, due to more width, it eliminates differential settlement. It eliminates differential settlement. So in raft, though the direct settlements are more, due to more width, it eliminates differential settlements. And in the case of sands or hard clay, and in the case of the soft clays, in the case of sands or hard clays, or in the case of the soft clays, see, sands or hard clays, they are going to be having less settlement or not. Compared to raft, isolated has a lesser settlement. So the permissible range over here is going to be 50 mm. The permissible range is going to be, the permissible range here over here is going to be 50 mm, which means if it is an isolated foundation, the foundation can settle up to 50 mm. That is a permissible limit, and you cannot go beyond 50 mm. And in the case of the raft, it is going to be 75 mm. In the case of the raft, it is going to be 75 mm. So in some textbooks, they have given this as a 40 mm and this is 60 mm also. In some textbooks, they have given 40 mm and 65 mm also. Both are going to be same, but you know the permissible limits are going to be generally according to IS code, it is going to be 50 mm and 75 mm. So there are a lot of codes were there. The earlier code says 40 mm and 65 mm. So, but I ask you to remember this one as a 50 mm and 75 mm only. Okay. Sands are hard clays, 50 mm. And in the case of the raft, as the width is more, the permissible settlement, you know that raft will undergo more settlement, right? Then you have to give more permissible value, 75. Whereas in the case of the soft clays, for isolated 75 mm and for raft, it is going to be 100 mm. So these are the permissible values of the settlements in the case of sands and clays under isolated and raft foundations. So majorly we go for this type of foundations only. That's the reason why we give permissible values for isolated and raft only. Sir, please respond which soil is better for the construction, sir. You tell me, sir, the soil which are having gravel has more bearing capacity. That is best for the construction. So that's all with this chapter. With this point, we have concluded. Shallow foundations. This is a quite big chapter, so please go through the notes. I have given and I have discussed each and every point which is required. And now let's see, there is one question. So please look over this question. Sir, in layered case, what about density soil? Should we take the weight average for that too? Yes, you have to take that. Show us slides, we will take screenshots. Don't worry, I will be sharing the PDF. Okay. Now see this question, solution. In a load test conducted at a depth of 1 meter below ground with a square plate of 30 centimeters. What is the width of the plate? 30 centimeters, which is going to be 0.3 meter. Square on granular soil. Granular soil means C is equals to 0. Load required to cause 25 mm settlement was 7.2 tons. So you know the immediate settlement is going to be Q by E into B into 1 minus mu square into I. Yes or no? So whatever the bearing pressure for this settlement is going to be, yes, is going to be directly proportional to Q. Okay. For the settlement 25 mm 1, what is the load that we have given for settlement S1 25 mm? What is the load required to cause settlement 25 mm was 7.2 tons. See, 7.2 tons means, can I find out the bearing pressure for this? What is the bearing pressure for this? The bearing pressure is going to be load by area of plate. So 7.2 by 0.3 square, because that's going to be square, right? Which is going to be 80 kilopascals, which means for a settlement of 25 mm, the bearing pressure I got is 80 kilopascals. 80 kilopascals. Now, if the settlement is limited to 10 mm, the allowable bearing pressure will be, if the settlement is going to be limited to 10 mm only, see for 25 mm, what is the load? 7.2 tons. And 7.2 tons means what is the pressure? You know that this is a plate and this is the load. So let's take this as a P1 instead of Q1. I'll be taking as a P1. So P1. So this is the base plate. So what is the pressure required to undergo this plate settlement of 25 mm is 80 kilopascals. Now for 10 mm settlement, what is the pressure? Q2 by Q1 is equals to S2 by S1. Q2 is equals to 10 by 25 into 80. So what is this value, please? 10 into 80 by 25. The answer is going to be 32 ton per meter square. Which method currently used at the site to find out SBC? Standard penetration test that we will be seeing at the end. So Nisarg is arriving at the Mumbai coast, so conclude the class. I'll be that already time is also there. And the people who are staying in Mumbai, please stay safe and don't go out unnecessarily, and in your home also. So please take all your food requirements necessary for you and use it sufficiently and enough. So we never know when the cyclone hits, we never know. And the people who are living in the low-lying areas, especially submerged zones, you please be safe. And you try to go to your relative homes who are in high-lying areas, because the most affected areas during the cyclones is nothing but the waterlogged areas or low-lying areas. So now that's about this question. 7.2 tons. So whatever the pressure that required is going to be 32 ton per meter square. And so based upon this, there was one previous gate question. With that, we'll conclude this. Yes. So you please look this question. Yeah. A strip footing of 8 meter wide. సార్ మీ ఇంటికి వచ్చేయమంటారా ముంబై నుంచి వచ్చేరా వచ్చే A strip footing is designed for total settlement of 40 mm. So the strip footing is designed for whom? 40 mm. And the safe bearing capacity was 150 kilonewton per meter square. So the safe bearing capacity is going to be given as 150 kilopascals, and the safe allowable pressure is 100 kilonewton per meter square. Safe allowable pressure means the pressure that soil takes safely without any shear and settlement. Without any shear and settlement. See, again, this is going to be this QA. See, just simply QNA, right? Now it is going to be QA. QNA means the net pressure, QA means the gross pressure. So this is going to be smaller of QS and QP. QS means safe bearing capacity. QP means safe settlement pressure. Safe settlement pressure. So now, given QS is more than QP, so QA is equals to QP is equals to 100 kilonewton per meter square. See, just simply I removed the NA, N, QNA, QNS and QNP. I just read as a QS, QP, because you know that once you know net, can't you find out the gross plus gamma D? So you know that here the strip footing is designed, the safe bearing capacity is 150, but the safe allowable pressure is going to be 100. Due to importance of the structure, now the footing is going to be redesigned for a total settlement of 20 mm. What is the new width? What is the new width? So for this is nothing but the safe settlement pressure for 40 mm settlement. For 40 mm settlement, what is the allowable pressure? This is going to be 100 kilonewton per meter square. Now I want to redesign for 25 mm. For S2, 25 mm settlement, what is the allowable pressure? What is the allowable pressure? So now you tell me what is the allowable pressure, please. What is the allowable pressure? So here the allowable pressure is going to be S2 by S1 into QA1, 21 by 25 by 40 into 100. What is this value? 25 by 40 into 100. This is going to be 62.5 kilopascals. 62.5 kilopascals. See, if this is the pressure, then for the given, what is the load, allowable load by area of the footing here? So what is the load? 100 into, what is the area of footing? Strip footing A into 1, which is going to be 800 kilonewton. Which is going to be 800 kilonewton. See, I am repeating the question again. The given is going to be the safe bearing capacity 150, but allowable is how much? 100 only. So you cannot go beyond 100, which means the soil will settle, soil will fail by settlement. So the given allowable pressure is going to be the safe settlement pressure, which is going to be 100. Under a footing of whom? 8 meters. So then what is the load you applied? 800. Okay. Now if I redesigned for the 25 mm settlement, what should be the load or what should be the new width of the footing. So now with this, I can write QA2 is nothing but Q by area of footing. So which means B2 into 1 is equals to 800 by 62.5. B2 is equals to, what is the B2 value? Please tell me. 12.8 meters. This question is similar to the question number 2 in the So what is QA2 is going to be 25 by 40 into 100, which is going to be 62.5. Then 62.5 is equals to load by the new value B2. So B2 is equals to 800 by 62.5. The value is going to be 12.8 meters. So the answer here is 12.8 meters. Answer as D. So that's all with this chapter, and one more thing, the last one with this will be ending. No other questions are there. I have given you this as a homework for you. So the NQ value is going to be 10, and the safe bearing capacity is going to be 270 kilopascals. You please solve this one. A plate load test is carried out on a 300 by 300 mm plate placed at 2 meters below the ground level. So this is the 2 meters below the ground level. And what is the plate size? The plate size BP is going to be 300 mm, which is going to be 0.3 meter. And determine the bearing capacity of 2 meter by 2 meter footing placed at the same depth on a homogeneous sand deposit extending 10 meters below the ground level. The water table is 3 meters below the ground level. Water table is going to be located 3 meters below the ground level. So which of the following factors does not require correction to the bearing capacity determined based on the load test? See, what they're asking is which of the following factors does not require any correction? Absence of overburden pressure during the test. Yes, there is no overburden pressure, so no overburden pressure. It does not require. Which of the following factors does not require a correction? See, overburden pressure, no overburden pressure, so you require a correction. You have to do the correction. Correction is required. Size of plate is much smaller than the footing size. Yes, because what is the footing size they have given? 2 meters. So if the size is going to be changes, then you know correction is required. What are the corrections? Those corrections are known as settlement correction and bearing capacity correction. Now coming to the influence of the water table, you see as water table is located, you see whatever this depth is nothing but 1 meter or not. Water table is located at a depth of 1 meter below footing. No correction is required. No correction is going to be required. See, I told you one point clearly. Have a look. If water table is located originally at a depth of 1 meter below the footing, no correction is going to be required. So here, as the given in the question itself, there is a question. Yes. As in the given question itself, the water table is going to be located at a depth of 1 meter below the footing. So you don't need to do any correction. So which of the following factors does not require a correction? Influence of the water table. Settlement is recorded only over a limited period of 1 or 2 days. Yes, it requires a correction, right? Because that's a limitation. What is the limitation? Whatever the settlement we get is immediate settlement. So we have to do the correction. So correction is going to be required. So answer is C. Answer is going to be C. That's all about the shallow foundations. With this, we completed each and every chapter. And I'm asking you people, you please go through the these corrections. There were a lot of questions in our previous GATE and IES. So I hope you can solve those questions also. I'm not solving those questions. Those are small questions only. And whatever the required data and the most typical models, I have covered all those in the classroom itself. First of all, if you want to go for any other textbook, go through the notes. And this data is enough for your GATE examination and IES examination. And mind it, for IES people, for mains, in this chapter, there are some extra topics we'll be discussing later. Some topics like Hazel's approach, Teng's equation, Hensel's equation, there are some other equations, IS code method. So those methods are important for the ESE mains. But according to ESE prelims and GATE, I'm telling you, Terzaghi's theory is very important. So that's it for today's class. And as most of the people are asking me to stop, so yeah, I'll be stopping the class today. So with this, we completed the foundations. So now I hope you please go through the notes once again. You go through today's class of entire bearing capacity and you be ready. So tomorrow we'll be starting the pile foundations. It's already 1:10. I'll be stopping the class today. So have a nice day for you, and the people who are staying in the coastal areas, be safe. I mean, right now in nowadays there is no meaning of safe. We have to do the safe only in the foundations, the safe bearing capacity and all those things. But in reality, we don't have any safe also. But try to be. And right now, home is the only safest position. So even in Hyderabad also, the climate is cooler and there is no much of temperature because of these effects. So hope so. The people who are staying in Mumbai especially, so the Maharashtra state is so vulnerable out of all the states in India. They have been affected with a huge amount of COVID cases, and right now with the cyclones. So take care of you, and I'll take some 10 minutes of, it's already 1:10. I'll be taking some 10 minutes of doubt clearing sessions. So those who wants to raise your hand, you can raise now. I mean, I'll be taking only 10 to 15 minutes. So those who wants to, Mr. Aditya, please speak out.
Hello.
Aditya, please speak out.
Hello.
Yes, Aditya, speak
Yes,
out.
sir. Sir, I have doubt in.
I'm not able to hear your voice clearly, Aditya. Please
Sir,
speak.
can you hear, sir?
Yeah, tell me.
Sir, I have doubt in previous gate question, sir.
Gate question.
Yes, sir. Last chapter, sir. Not this chapter. Stability of slopes.
In the case of the stability of slopes.
Yes, sir. 15th question, sir. 2 marks.
Give me a minute, please. I am checking the.
Yes, sir. Yes.
Uh, so gate question, right?
Yes, sir.
15th chapter. Question number, please.
Sir, question number 15, sir. Stability of slopes.
Question number 15, 2 marks question. Yes.
Yes, sir.
Yeah, what's there in that?
Sir, in that, sir, they have not specified any seepage condition, sir.
They have given the water table, right? You see the water table here?
Yes, sir. Can we assume it as submerged condition, sir?
No, you cannot assume. The submerged condition looks like this. The submerged condition looks like this. This is submerged condition. Okay.
Okay, sir. Okay. Yeah. That's it, sir. Thank you.
Yeah, okay, fine. Page number 770, question number 41, please explain the ESC. ESC. Next. Miss Sindhu, please speak out. Miss Sindhu, please speak out. Miss Sindhu, please speak out. Okay. Mr. Sachin, please speak out. Mr. Sachin.
Hello, sir.
Yeah, Sachin, tell me.
Sir, from chapter number 14, 2 more questions.
14.
Gate, sir. Gate, sir.
Gate, chapter number 14, yeah, tell me.
2 more questions, 7 questions.
What?
2 more question.
2 more question.
7th one.
Chapter number 14.
Chapter number 14.
Okay, what's there in it? Tell me. I think
Sir,
this question. Yeah, tell me.
I solved this question, sir, but I got answer as 39.7.
39.7.
Yes.
So what they're asking is total active force per unit length in
Per unit length.
meter. So
yes.
we have given C5, C0 values, and you have to draw the pressure distribution first. Have you drawn?
Yes, sir. Yes, sir. Yes.
So if you have drawn the pressure distribution, there is no surcharge also. At the top, it should be 0.
Yes, sir.
0.5 Ka1, just above Ka1. So Ka1 into whatever, this is nothing but gamma into 2. Just
Gamma
below,
into 2.
Ka2 into gamma into 2.
Yes,
And at bottom, Ka2 into gamma. This is soil 1, right? Gamma 1.
yes, sir. Soil.
Gamma 1 into 2 plus gamma 2 into 2. So have you solved these ones?
Yes, sir.
K1 is going to be how much? So the K1 value is going to be 1 by 3.
1 by 3, sir.
Yeah. And
K2 as 0.21. 0.21. 0.21, sir.
0.1. You have substitute. Let me check. What is the answer you got?
39.7, sir.
I'll check. If this is the procedure, you would have got that answer. But let me check.
Yes.
Question number 7. 31.7, that's the correct answer. 31.7 will come. Because if you solve, I hope you got just above this value is going to be 10 kilopascals.
Yes, sir. 10 kilopascal.
Just below 6.51.
6.3, sir. 6.3.
6.51 it is coming. You please check it once.
Yes, sir.
And at the bottom it should be 15.19 kilopascal.
I got as a bottom wall as 14.7, sir.
Okay, you please check that one because I think you may have done some wrong in the KA2. Value is 0.7 you have take. 3 decimals you take. 0.217. Don't take 2 decimals.
Oh, okay, sir.
Okay.
Oh, okay, sir.
Yeah.
Thank you. Thanks.
Miss Sanjana, please speak out. Miss Sanjana, please speak out. Miss Sanjana, please speak out. Miss Sindhu, please speak out. Miss Sindhu, please speak out. If you don't want to speak out, then please don't raise your hands. Don't waste the time. Ovia. Mr. Ovia, please speak out. Mr. Ovia, please speak out.
Hello, sir. Can you hear me?
Yeah, Mr.
Sir, doubt in previous year gate question, sir. Chapter number 4. Sorry, sir. Yeah, sorry, sir. Earth pressure, 14th.
Okay, which question?
In that 9th question, sir. 9th question. One more question. 9th one.
The classroom, right?
One more question, sir.
One more question. Okay.
Yes, sir.
9th question. That's effective only.
Sir, why can't we take the total stress, sir? Actually, the equation is
see, if there is a water table, the coefficients are not going to be applied for the pore water pressure. It will be applied only for the effective stresses. In the class itself, I told you that Ka and Kp are applicable for effective stresses only.
Okay, sir. Okay.
So the answer is going to be this one.
Okay, sir. Okay, sir. That's it, sir. Thank you, sir.
Yeah. Okay. Fine. Mr. Manikanta, please speak out. Mr. Manikanta. Mr. Manikanta, please speak out.
Am I audible, sir?
Yeah, you are audible to me. Speak out.
Sir, 15th chapter, 2 marks question number 16, sir. 15th chapter, 2 marks, 16th question.
15th chapter, 2 marks. 2 marks?
16th question, sir.
16th question. Yeah. Those who wants to listen this, you can see, you can listen also this one. See, actually, where is it? If you observe, they have given a soil mass up to this point, okay? And the soil mass depth is going to be 2 meters, and below this is going to be 4 meters. And this is the point A. At point A, they give C dash, phi dash, and undrained shear strength. What is the undrained shear strength? U. So 80 kilopascals. This is a drained parameters, and here it is going to be undrained parameter. Unit weight of the water is given as 9.81 kilonewton per meter cube. Unit weight of the soil above is 18. So gamma sat is going to be 20. If a shear at point A is 50, point A, they mentioned the shear stress as 50 kilopascals. Now, what is the factor against the shear failure at this point? Considering undrained and drained conditions would be. They're asking considering drained and undrained conditions. See here, first about undrained condition. In the case of the undrained condition, what is the factor of safety? What is the factor of safety generally? Shear stress by shear strength. Yes or no? Mr. Manikant, I hope you are audible.
Yes, sir.
Yeah. So as I asked you undrained, then S becomes yes. What is S you given? 80 by 50. What is 80 by 50, please? Which is going to be, I hope so, 1.6, huh?
Yes, sir.
Yeah, 1.6. And now coming to the drained condition, in the case of for the same question, now drained condition. In the case of drained condition, they are given the factor of safety S is equals to S by tau. Now S means C dash plus sigma dash into and phi dash by tau. Already they mentioned the tau value. As you know, in the undrained they have given SU, you can find it out. Now we need to find out. Now we need to find out the effective stress. So at a point A, effective stress is equals to, you see, in this 2 meters, gamma into 2 plus in this 4 meters, water table is there or not? See, this is nothing but a water table line. Whatever, this is nothing but the water table line. So gamma dash into 4, gamma into 2, 18 twos plus gamma W they have mentioned as 9.81, 20 minus 9.81 into 4. Please tell me this value. 20 minus 9.81 into 4 plus 18 into 2, which is going to be 76.76. Now, what is the factor of safety? Mentioned as a 20 plus 76 into tan 18 degrees by tau value as 50. Please find out the factor of safety. 76.76 into tan 18 plus 20 by 50. It is going to be 0.89. The value is going to be 0.89. I hope Mr. Sai Krishna, Mr. Manikanta, I hope you understood this.
Yes, sir. Thank you, sir.
Yeah, okay. I'll be sharing this question also for everyone. Okay. Yeah. And remaining questions. Today's last call. Again, mute yourself. Hello.
Hello. Hello, sir. Am I audible?
Yeah, you're audible to me. Tell me.
Sir, I have a doubt from ESC, sir. ESC shear strength question number 75.
ESC shear strength question number
75, sir. Last one.
Can you please tell me the page number? Yeah, shear strength, which question? Please tell me.
Question number 75, sir.
Yeah, actually, see, this topic is, I'll say now. See,
Page number 79.
Yeah, understood. Every year, these type of questions will be appear here. Actually, this is just based upon, this is based on the relation between undrained shear strength Cu and effective stress. This relation Cu by sigma naught dash is equals to some, give me a minute once. There's a one relation. So that is going to be 0.11 plus 0.11 0037 into IP, where IP is known as a plasticity index. See, this is just a relation. These type of questions will be asked once in a while, but if you ask me in the GATE exam, means in a IS examination, if you come through these questions, you just skip these type of questions. Every year they will ask you one question because you cannot cover each and every topic, right? Am I audible to you?
Yes, sir.
So these type of questions will be, it's better, if my suggestion is, it's better you skip these type of questions. Do not waste much amount of time. See, this is just once in a while asking question, relation between the undrained strength and sigma naught dash. So here they have a liquid limit, plastic limit has a 60% and 50%. This is liquid limit. This is the plastic limit. Saturated limit is going to be 19. Water table is at a depth of 8 meters below the ground level. And at a depth of 10 meters, the undrained shear strength. What is the meaning of undrained shear strength? Cu. So if this is a ground level, and if this is a 10 meters, at a depth of 8 meters, so there is a water table above gamma, below gamma sat. Assume gamma is equals to gamma sat. As I did not mention any gamma value. So then at a depth of 10 meters, what is the sigma naught dash? Overbottom pressure, right? So
Yes,
this
sir.
will be like gamma into 8 plus gamma dash into 2. So gamma, and how much gamma they have mentioned? 19 into 8 plus 19 minus 10 into 2. 19 into 8 plus 19 minus 10 into 2, which is going to be 170 kilopascals. So now if you substitute Cu by 170 is equals to 0.001, 0.0037 into IP, liquid limit 60 minus 30. You please solve this one, you can get the values.
Yes, sir.
0.0037 plus into T plus 0.11 into 170, 37.37 that will be coming as. So the answer is going to be, see, I did not discuss this topic. Why? Because this is once in a while. We cannot waste our time in these type of topics. Every year, if we get 100% out of 100%, every topper would be getting 100, right? Okay, so if you want to remember, you remember, else it's up to you. That's it, my dear.
Thank you, sir.
Yeah, okay, fine. So with this, means I have to conclude this. And whatever the remaining doubts, I'll be seeing tomorrow. So I have to leave. And within no time, our session is also going to be end. So that's why I'll be saving this first. Yes. Okay, fine. We'll see the remaining things tomorrow. Sir, IS previous year earth pressure question number 41, page number 88. Sir, please. My dear anonymous attendee, you please mail to me. I'll try to reply through that.